will see why should you learn Python and what are the advantages of choosing Python over any other language to learn programming. Now let us start with our video. If you are a college graduate and want to have exciting opportunities in IT industry, or an unexperienced or a person with little bit experience in software development, or you are an experienced developer but want to change in career, this series is for you. In fact, this series is for everyone who want to learn Python. By the end of series, you will be able to confidently apply for big companies and able to clear their interviews without any doubt. And you can also apply Python to your projects and add these projects to your resume. If you are new to software development, then also you should be choosing Python over any other language because of its market demand and low learning curve. If you are an experienced developer, then choosing a Python will help you to work in latest technologies such as data science, machine learning, artificial intelligence, and many more. It will provide you many more opportunities as compared to your colleagues who are working in any other technologies. Now let us see what is Python programming. Python is a high-level programming language used for general purpose software engineering. It is a server-side language, which means it runs on a server and responsible for processing logic behind user input, interacting with database and other servers, etc. It was initially developed in 1980s. Python has around for decades alongside other languages. Python is an open source language, which means you can access the code of Python on its repositories and you can also recommend modifications and you can contribute to the Python development. Python also has a huge community around machine learning, data modeling, data analytics, artificial intelligence with extensive resource and libraries built for this purpose. Python is extremely versatile and it has multiple uses. For example, Python is used for data mining, data science, artificial intelligence, machine learning, web development, web frameworks, embedded system, graphic design, game development, network development, product development, rapid application development, testing, automation, scripting, and the list never ends. Python is used as an easier and more efficiently written alternative that can perform similar operation like R, Java or C. Therefore, Python is growing popularity as a primary language for many applications. Now let us see Python's uses in data science and machine learning. Previously, R was the most important language used for data science. But as Python code is considered to be easier to maintain and more scalable than R, Python has increased its popularity for data science, especially among professionals without advanced education in statistics or mathematical field. In past few years, many packages have been developed for data analytics, machine learning using Python. These include NumPy, Pandas, which allows user to transform data. TensorFlow is an library used for writing machine learning algorithms, and we also have PySpark to work with Spark, which help to manage and maintain a very huge databases which size can goes up to petabytes. Now let us see how Python is used in other industries. Python is used in many companies such as recruiting, healthcare, financial services, marketing, education, and many more. In healthcare, Python is used to predict size of tumor and cancer cells. For startups, Python is great and quick for prototyping, hence used extensively by many startups. Given Python's uses across many industries and applications, and its recent explosive use in data science, machine learning, and AI, Python is on major growth trajectory. You can also analyze the Stack Overflow graph to see the Python trajectory, which is rapidly increasing. Python is in high demand for jobs. Python ranks 2 in most in-demand programming languages in 2020-2021 with respect to LinkedIn survey. Python is the fastest growing programming language. Python is easy to read, write, and learn because Python was built with a goal of getting rid of complex and keeping only necessary things. Because of this, Python has become easier to read, write and learn, and easier to grasp, and thus have make the number one choice for newbies to learn Python. Python is an interpreted programming language, which means unlike compiled language like C++ or Java, you can run each line of code as soon as you finish writing it. This gives a Python a superpower because of which you can see where exact errors are located in your code. Python developers also make great money. On an average, Python developer earns more than $1 lakh per year in US. Python has a great supportive community, which means if you have any doubts or any error in your program, you can always ask Python communities or Stack Overflow or any other website, and you will get a great help from the developers community. Python has a rich ecosystem of packages because of which you can do anything you want in Python. For example, you can use Pandas for data exploration, TensorFlow for machine learning, etc. So after this, I hope your interest to learn Python has been elevated. I hope you are as excited as I am to learn Python. So go to your favorite browser and search Python. Now choose the very first site, which is python.org, and go to the official website. And on this website, you will see the documentation, the community, and news, everything you will need to know about Python. So here we are currently interested in download. So we will click on it. So here you can see we got an option for downloading. So if you are a Mac user or Linux user, you can see here the options are given. But currently we are on Windows, so I will click on download for Windows. So now our download has been begun. So we will wait until it completes the download. Now our download has been completed, as you can see in the corner. Now to start with installing, you have to click on it. Now on this dialog box, you have to click on add Python to path, and then you have to click on install now. So make sure you click this option. Then you have to click on install now. And now our setup process has begun. So until it is installing, we are now on Python documentation. So if you got into any trouble, then you can always visit to Python org website and search for the issue. You will get your answer. Now the setup has completed. Now you can close this dialog box, and in the search you can search for Python. So here I can see Python 3.10 has been installed. So you can click on that. So this is Python terminal. So here you can interact with Python. So if you have some script to run, then you can directly type that script over here. For example, if I want to print something, so then I will just write here. Suppose I want to print, let's say, hello. Then I will complete the bracket and enter. So it has printed hello. So here you can run any complex script you have. So this is the Python terminal. So let us install the IDE for running Python. So there are many IDEs available. So you can choose one of them for you. For example, there are Visual Studio Code. We also have Sublime and Pycharm. So Pycharm is one of my favorite. So for this video series, we will go with Pycharm. So let us search Pycharm and hit enter. So here is the official JetBrains website. Here you can download Pycharm. So I will click on it. Now here you can see we have an option for download. So there is a paid version for professionals and community version for the developers like us. So let us download that. So the download has been started, as you can see here. So I will pause the video until the download finishes. So my download has been completed and here we are in a download folder. Here you can see the Pycharm community edition has been downloaded completely. So I will click on installer, click on next. If you want to create a desktop shortcut, you can click here and also add bin folder to the path as similar to we have done with Python. So let us click on next and click on install. So our Pycharm is getting installed. So let us wait for it. So we have installed Pycharm here and I have to reboot my system now and we will see all the features of Pycharm there. We will see how to use Pycharm efficiently. So when you will open Pycharm for the first time, you will get the screen something like this. So from here you can either start creating a new project or you can open the existing project that you previously have created. So we don't have any project up till now. So we will start with a new project. So I will click on new project. So what is the name of project that we have to view, that we have to mention here? So I will write here Python examples. So after clicking create, it will create a project for me. Let us wait for some time. So now it has created a project and it has given me some code to start with. So here is the directory where I have created the project, and here is the main file that we are accessing currently. So let us clear this code and let us start with a clean slate. So I have cleared all the code. So if I want to write a code here, so how should I start? If I want to print anything in Python console, I just have to use a print statement. So if I use print hello world, then I just have to write this much code to write hello world into the console. And in order to run the code, you can either right click on this file and click on run main. So this main will be the name of the file that you have open currently. So after right clicking, you will get the option to run and the name of file which you want to run. So after clicking run main, I will get hello world in the console. So this is called the Python console. So here you will get the output. So also you can give input to the Python program if you want to from here. So if you have got this output, so congratulations for writing your first Python code and getting the output without any error. If I want to print hello and the name of person here instead of the world, so how can we do that? So in Python, we have input method to take input from the user. So let us see that. So I want to enter a name. So I will write here name. And to get input, I just have to write input. And into the round brackets, you can write your message that user want to see. So here we are accepting the name. So here I want to show the user that you have to enter name here. So I will ask him to write the name. So I will write please enter your name. So this message will be shown to the user, and I want to print instead of world, I want to print the name. So let us remove the world and I will use comma. and write here name. So hello comma name, so it will print hello first and followed by that it will print the name. So let us try and run the code. So here I have got the line that I have written here, please enter your name, and here the same thing is written, please enter your name. So I will write, let's say John. So this is the input I am giving to this program, and when I enter, so when I click on enter, it will give me hello John as the output. So this is the input and this is the output that this program has given to me. So this is how you can give input and this is how you can get the output from the program. So if you don't want to right click and run the code again and again, so here is the shortcut, and when you click here you will get the same thing. Let's say Charlie, click on enter and I will get the answer as hello Charlie. Either you can click here to run the code or you can right click and click on run main to run the code. You can also use the shortcuts like Control F5 to run the code. So to create new files in our project directory, you can right click on the directory and click on new. I want to add a new Python file, so click on Python file and give a meaningful name. For example, if I want to create a program to add two numbers, so I will give it a name as add two numbers. So always try to give a meaningful name and hit enter. So add two numbers file has been created. So here you can type your code, and if you want to delete the file, then you can right click and here is the delete option to delete it. But before that, if you want to rename the file, then here in the refactor option there is rename here. So here you can click on rename and change the name of file to add two numbers, let's say version 2, and click on refactor. So our file name has been renamed. So this is how you can rename the file name. If you want to delete the file, you can go here and click on delete and click on OK. So this is how you can delete the file. If you have done everything right and got an output, so many congratulations to you for writing your first code, getting input from the user and seeing the output. And we will see all the functions of Python and how you can write the code, and we will also see some standard practices used by developers to write code. You have wrote your first Python code. Let us see some basic examples. So we will right click on the Python directory and click on new file and select Python file. So let us create a program to add two numbers. So I will give it as a name, add two numbers, and hit enter. So the new file has been created. So let us take two numbers from the user. So num1 is, I will say input, and give message to the user, enter first number. So by reading this message, user will understand that he has to enter the first number. Then num2 input, enter second number. By seeing this message, user will understand that he has to enter second number now. Now I have to store the sum of these two variables somewhere. So I will create a third variable, let's say num3. It will be sum of num1 and num2. So in the num3 variable, I am storing the sum of num1 and num2. So the value of num1 and num2 I am accepting from the user. So after adding these two variables, I have to show sum. So in order to show the sum to console, we have print statement. So I will use print and I will write num3. So let us run the code and see the output. So I will use shortcut to run the code. So it is currently asking me to enter first number. So let us enter 12. And when I hit enter, it is asking me to enter second number. So I will write here 13. And again, after hitting enter, I am getting 1213 as output. This is because it is considering these number as a string and adding those numbers as a string in a series. So in order to avoid this condition, I have to typecast this number into integer. So how to do that? I just have to cover num1 into a round bracket, and in front of that I have to use int. So this will convert this number into an integer. So similarly, I will write integer and cover this num2 into round brackets. And when I run this code again and enter 12 as a first number, hit enter. So it is asking me second number. So I will write 13 and hit enter. So here I will get correct sum this time. So this is how you have to write the program to add two numbers. So by default, input will take string as an input. So you have to convert that string into integer. So to convert string into integer, we have int. So you also have noticed that when I am typing the code, it is giving me some hint. So every good ID will give you hint while you are typing. So if I write PR and the hint is print, so if I want to use that hint without typing the whole print word, so I just have to hit enter and it will give me the print statement written fully over here. Similarly, if I want to use num3, then I will just write here n and it will give me all the numbers. So I have to write num3. So I will use down arrow key to move down and click enter. So I will get num3 here. So similarly, if I want to type input, I will just write inp and I will get the input, and when I hit enter, it will complete that sentence. So in this way, you can save some time by using built-in hints in this ID. Also, we have terminal here. So by using this terminal, you can interact with Python. So when I type Python and hit enter, it will open the Python shell. Here also I can type the code. For example, if I want to print, let's say what is 12 plus 13 and hit enter, I will get the solution. So you can use this terminal to run some short scripts. Also, you can practice your code here. So whenever you have such short scripts, then you can use terminal and type those script out and see your output. So in this way, you can use the terminal. We can also debug our code in Pycharm. So to debug the code, you can move your arrow over here and I can click here. So when this red point has appeared here, this is called a breakpoint. So the Python will start executing from here, and whenever he will see the breakpoint, it will stop the running of code. So to debug the code, we have this option. So when I click on this, so our code has been started with debug mode. So it is on the line first. So it is asking me the first number. So let us give it as a 12. So it is on the line 2 right now. So I have entered 13 and enter. So as soon as it reaches the breakpoint, it will stop the execution, and here it will give me current state of variables, that is num1 is 12 and num2 is 12. Now here are some options that has been given to us. So I can click on step over. So when I click on step over, it will skip that line. When I click on step into, then it will execute this line and go to the next line. And similarly, you can see all other options. So let us click on step into. So it has executed this line and gone to the next line. So it has given me the state of num3, which is 25. And when I click on the next, so program execution has done. So the debugging mode has been automatically closed. Now I hope you have understood how to use Pycharm IDE and how to write code into it. We will see the theoretical part about variable declaration and memory allocation. So let us start with the question, what are variables? So variables are just a name given to the memory locations where the data is stored. For example, consider this as a bucket and it stores some values, let's say 1000, and this bucket has a name, let's say its name is num. So it is a bucket named num and it stores the value 1000. So in this analogy, this bucket is a memory cell and the name is the name which is given to that memory cell. Now we have many data types that we can store in these memory cells. For example, we can store integer as we have written here. Then we have strings. Now strings are always enclosed in either single quotes or double quotes. So you can write a string, let's say name. Then we have list. List is a collection of data. Then dictionary. Dictionary has key value pairs and so on. We will be looking each of them in detail. Now let us see how memory is allocated. For example, if I have a variable named num and it is assigned with 100. So Python will see if there is 100 in memory location. So if there is no 100 previously available in memory location, so it will create a new memory location with 100 in it. So let us consider this as our memory locations, and we have many memory cells available where we can store data. So we have created 100 for our num. Then Python will see the variable name is num. Then it will point that num to this 100. So num will be pointing to this 100. Now I have to use another num2 with the same value of 100. Then what Python will do is it will search for 100 in memory locations. Then it will see we already have 100 available. Then it will just point num2 to the same memory location. So it will not create again 100, but it will use the same 100 and pointing num1 and pointing num and num2 to the same 100. Now if I required num3 as 200, then Python will search if there is 200 available. So there is no 200 available, then it will create a new memory cell with 200 in it, and num3 will be pointing to the 200. And if I write num4 as 200, then it will again see if there is 200 present in our memory location. So it is there. So num4 will be pointing to the same memory location. So this is how memory allocation is done in Python. So I hope you have understood how memory is allocated in Python. Let us see how to declare variables in Python. So Python is not a statistically typed language. What does it means is we don't have to specify the type of variable before declaring it. For example, I don't have to specify int a if I have to declare integer. Instead, if I want to declare an integer with name a, I can directly use a and assign it a value as 10. So I don't have to specify here whether it is an integer or whether it is a string or anything else. Python will automatically understand the type of variable after the value has been assigned to it. So it is very important while initializing a variable that we have to declare value. So while initializing a variable, we have to declare a value for that. Now the value in a variable can be changed anytime during program execution. For example, I have write a is 10. If I try to print a and run the code, I will get as 10. But here if I write a equals to 20 and when I print a, then the value of a has been changed to 20, which means we can change the value of the stored variable anywhere while the program execution. Now let us see some rules while initializing a variable. So variable name cannot start with a number. For example, if I try to start the name of variable with a number like say 3a and assign it something, then it will give me an error. So we cannot use that. And it must start with an alphanumeric character, for example a, and if I run this code now, it will not give me an error. We also cannot use dash between the name of variable. For example, if I try to write a dash b and run the code, I will get an error because dash is reserved for subtraction in Python. So that is the reason why we cannot use dash between variable. Now variable names are case sensitive in nature. For example, if I have declared a is 12, when I print a and run the code, it will give me 12. But if I initialize capital A equals to let's say 21 and print capital A and small a at a time and run the code, I will get two different values because small a is different than capital A. So variable names are case sensitive in Python. So variable name can only start with letter or underscore character, which means I cannot start variable name with some symbol like exclamation A and assign it a value. It will give me an error. Similarly, I cannot use a numerical value in front of a variable. It will also give me an error, but I can use underscore to start a name of variable and it will run perfectly fine. I can also use double underscore and run the code. It will also work. So variable name can only contain alphanumeric characters and underscores. That means I can use a underscore b as a name. It will be valid, and a underscore b underscore c will also be a valid variable. So this is how we can initialize variables in Python. Now here are some suggestions while initializing a variable. So first suggestion is try to use meaningful name for variables, which means if I want to declare a variable for name, then I must give the name of variable as name and I should define a name by using equals to sign. Let us take some another example. If I want to declare a variable for age, then I must give the name of variable as age and let us say the age is 90. Similarly, if I am only giving the first name here, then I can also change the name as f name or first name, so that will add more meaning to this variable. So this is the first suggestion. Then the second suggestion is try to not to use name of built-in function or reserved words. For example, We have list in Python. So list, list is a reserved variable, and if I assign it to some value and print list, it will not give me any error, and it will also give me a correct value. But it is a strong suggestion that we should not use the built-in function names or reserved words as our variable name. So these suggestions will not give me any error if I do not follow them, but these are the standard practices everyone should follow. So the another person reading this code will understand it. For example, if you hand over this code to your friend should know this variable will store only the first name of the person, and this variable will store the age of the person. Similarly, if you try to use the built-in function as a name, during interpretation of this code, the Python may get confused between built-in function and variable, or you may get confused during using these variables. Then we have type and ID. So a type function will give me what type of variable it is. So let us comment this out. And if I try to print type of A, I have to print it. So I have to enclose them in a rounded bracket and use print statement. When I run the code, I will get it is a integer. Similarly, if I declare some another variable, let's say last name as Walker, and I try to print type of last name and run the code, I will get it is a string. So this is how you can use type variable to see the type of variable you have declared in your code. Then we have id variable. Id variable will give me the id of memory location where the variable is stored. So whenever you initialize a variable, the memory is allocated in Python, and you can use id function to find the id of that memory location. For example, if I print id of A, then I will get the id of that memory location. Similarly, if I try with last name and run the code, so I will get different id. Now every time I run the code, I will get different id for the last name. So here is 568, and when I rerun the code, I will get 664. So every time you rerun the code, the new memory allocations are done for each variable. So every time you run the code, you will get different id for the same thing. Now let us declare A as 12 and B as 12. Then what should be the id of A and B? So let us run the code. So id of A, and I will run the code again, and id of B. So you can see that both of the IDs are same. This is because when we initialize a variable, Python create a memory cell. Let us consider this as our memory cell. So these are our cells. So when we initialize A as 12, then Python will store 12 here, and then it will create a variable named A, and it will be pointing to 12. And when we create a B as 12, then Python will see the 12 has been already stored. So it will just create a B and point it to same memory location. So it will create another variable B and point it to same memory location. But if I try and update B to, let's say, 21 and run the code, I will get a different memory location, because 21 has different memory location than A. This is because it has created another memory cell, and now B is pointing to 21 and no longer pointing to 12. Similarly, here I have created last name variable and assign it a Walker. So Python will create a memory cell with Walker in it and assign the last name to that memory location. So in this way, Python will store data in the memory cells. So let us summarize all the things. So Python is not a statistically typed language, which means we don't have to tell Python which type of variable it is. Python will automatically understand the type of variable. Now variable value can be changed anytime during the program execution. For example, here A was storing 10, now A is storing 20. So we can change the value of variable anytime during the program. So variable is only name given to memory location. This point we have seen here. So variable is only the name given to that memory location. So A is only pointing to that memory location, which is printed here. Now, rules for writing variable in Python. So we cannot start a variable name with number. We cannot use dash between the variables. This is because dash is used to use as subtraction in Python. So variable names are case sensitive. So capital A is not equals to A, or capital first name will not equals to the small case first name. So if I write, so this will be different from the first name with capital N. So variable name must start with a letter or underscore character. So you can start with a letter or an underscore character, but not any symbol or a numerical value. Then the fifth point is, so variable name can only contain alphanumeric character and underscores. This means I cannot use symbols between the variables, but if I try to use numerical values between the name of variable, it will not cause an error. So this will work perfectly fine. Then there are some suggestions. So the first suggestion is try to use meaningful name for the variable, because if you pass this code to your colleagues, then they must understand your code. Now try not to use name of built-in function or reserved words in Python as your variable names. By doing this, it may confuse you or the Python while interpreting. Now type is used to say the type of variable, and ID is used to check the ID of memory location of the variable. While initializing variable, Python stores the value at memory location, and the name of variable is just pointing to that value. So when we create another variable with the same value, it will be just pointing to that location. So this is how memory allocation is done in Python. So I hope you have understood how memory is allocated in Python. We will look much more detail about list, tuple, dictionary sets, data types. In this chapter, we will see what are the built-in data types provided by Python. So let us go to our Pycharm window, create a new project, name it data type. Now we will see each of these in detail. Now we have seen variable as a bucket which can store the data. Now let us define some variable name for first name and give it a value, for example Harry, and let give the last name and give it a value Jonas. So we have two strings with the first name and last name. The first name is enclosed in double quotes and end with double quotes. So by this, Python will understand this is a string. We can also use single quotes. So if you want to print the type of first name and also the type of last name and run the code, we will get them both are the string. Now let's move to the integer. Now integer and float are numbers. For example, if I want to store some mobile numbers, uh, then I can use integer. For example, mobile number is something like 99999 and so on. Then this mobile number variable will store the number, and for the float we have something like salary. So if someone's salary is 90.085, then we can store uh, like this, and it will be considered as a float in Python. We can also print the type of salary we will get it is a float. And if I want to print salary, I can use comma in the print statement and write salary over here. Run the code, I will get salary. Now let us move to list and tuple. So list is initialized by using square braces. I will write it here. List is initialized by using square braces and tuple is initialized by using round braces. So I have a list for collection of numbers, so I can give it a name, collection list, and I can write some numbers in here. I can also specify string values, string 1, string 2. I can also store the variable like mobile number in here, and I can also store list inside list. So this is also possible. I can also specify tuples into the list also. Let's say tuple with 98 and 43 value. Then we have collection, then we have tuples. Then we can specify collection tuple by initializing it by using round braces. We can also store the same thing as list in tuple. I will just copy the data from the list and paste it into the tuple. So this will save us some time. Okay, done. So we can print the collection list and collection tuple. So both of them are printed. If I want to print them in a new line, I will use a separate print statement. So they are printed on a separate line. I can also check the type of the list. Let's say I will write type of collection list. I will get it is a list. Let us remove type for a second, and for knowing the difference between tuple and the list, the tuple is a immutable object. We cannot change tuple. I will write it here. We cannot change tuple. That's why it is immutable. And for the list, if I write collection list dot append some values, for example 999, and I run the code, I can see 9999 is appended to the list. If I try same thing with the tuple, I write collection tuple dot append and the same thing, I will get tuple object has no attribute append. That means we cannot change anything in tuple, but we can add or remove characters from the list. So let us move to the dictionary. So dictionary has key value pairs. I will write over here. Dictionary has keys and values which are defined by separating colon between them. For example, keys colon values. Suppose I have a dictionary of words, like for example words dictionary, then I can initialize the dictionary by using curly braces. I will also specify it over here. We can specify using curly braces. And to write, like for example, I want to write the meaning of words, for example words, then the meaning of word is it is a collection of characters. If I want to specify the what is one resembles to, so I can use one colon and 1 is a number. This also works fine. So this is how we initialize and add some values to dictionary. Then we can also also print the dictionary using print statement, print word dict and run the code. The dictionary is printed in the console. So if I want to access something from the dictionary, we have to use square braces. Then inside square brackets, we can add the string. If we want to access the key, which is a string, then I have to specify double quotes and give the words. And when I run, I will get the value which corresponding to the words. That is, it is collection of characters and it is collection of characters. Similarly, if I want to access 1, as 1 is a number, I don't have to specify double quotes and I can directly write 1 and run the code, and I will get the output 1 is a number. So this is how we can access the things from dictionary. Then let us move to the sets. The sets is also initialized by using curly braces, but sets do not have key value pairs, and set is unordered and unchangeable, and they do not allow duplicate values in them. So we will understand them in detail. So let us declare a set of numbers and initialize them with curly braces. Add some values to it, 1 2 3 4 5, and print set numbers and run the code. We will get sets into the console. And to understand it does not allow duplicate values, let's try and add some duplicate values to it. Let's add 1 2 and 3 again and run the code. We can see that nothing has changed. That means we have declared 1 2 3 again in the sets, but it will not consider those because those are duplicate and already declared. So this is sets, and now let's move to the boolean. Now boolean, they can be a true or a false. So let's say I have condition. Let's say I have variable name condition, and I can initialize them with a true. Then it will be a boolean variable, and when I print condition and run the code, I will get the true statement in here. I can also declare with them false and run the code, I will get false. You must have noticed that I haven't used double quotes in here because uh, the true and false is defined in Python, and they are not considered as a string, but they are considered as a boolean. So we can directly write those as true or false without using quotes. So I can also define condition as like 1 is greater than 2. If the 1 is as 1 is not greater than 2, the condition is false. So when I run the code, I will get false. But when I reverse the condition, 1 is less than 2, it is definitely true. And when I run the code, I will get it true. So this is how we work with Boolean values. We'll be learning about strings in detail. Now let us go to our Pycharm window. In Python, anything that is enclosed in either single quotes or double quotes or triple quotes is a valid Python string. Now let us see an example of a string. Let declare a string name string. Let give it as a value. It is a valid Python string. Now strings are immutable. Let's copy this string, paste it here again, and we will change the values of it. Now let us see what is the memory allocated by Python to it. Let us see the ID of memory location. id of string. We will copy the code over here. Now we will run the code. You can see the memory location of the first string is different from the second string. That means Python has overridden the string and not changed the string at same location. That means we cannot change the string. Now the strings are ordered. In Python, anything which is ordered, we can apply indexing, slicing, and stride over that. Now let us see what are those in detail. Let us start with indexing. So indexing, by using indexing, we can access each element of a string. Let us copy our example here. Now let us try to print some part of string. I will write a name of string here and I use square brackets, and if I want to access some element of the string, like I want to access the I can use 0 over here, because in Python strings start with 0. I will write here index of strings start with 0. That is, if I write 0 over here, I will get the first item, that is first character. Let us run the program. I have got I in the console. If I want to access T, so I will write 1 over here, because indexing start with 0. So 0th element is the I, and second element T belongs to the index 1. When I run the program, I will get T. Similarly, if I want to get the space, I will write here 2 and run the program. This is the space we have got. Let us move to 3 to check it. It got that I. That is the fourth character. Now, one more thing about the indexing is Python has two types of indexing. One start from left to right and other start from right to left. How to access from right to left? I use negative signs over here. If I write square brackets and -1 and run the program, I will get the last letter. If I want to check the last second, then I will use -2 and run the program. I will get the N. Remember, when we start from left to right, here index starts from 0, 1, 2, 3, and when we start from right to left, index start from -1, then -2, then -3, and so on. Now let us start with slicing. If I want to get particular part of the element, then I have to use slicing. Suppose I want to print only it from the string, I will write 0 colon 2, because the index of I start from 0 and ends at 1, but Python exclude the last value, therefore we have to write it up to 2. By this, Python will access 0th element and 1. So let us print I have got IT. If I want to get up to it is a, then I will count those numbers 0, 1, 2, 3, 4, 5, 6, and 7, because 7th one is excluded. So let us copy this string and 0 till 7, and when I run the program, I got it is a. Now if I want to print from T to the whole string, then I have to count all the numbers, but there is a shortcut in Python. We have to use the index of T because we want to print T, and we don't have to include the last element. Then Python will consider the whole string we have to print, and when I run the program, it starts from T and ends up to the last one. If I do not include the first element and include the, let's say, seventh element, then Python will understand we have to start from 0 and end up to 7, and we got it is a. So this is how we can access. So this is all about slicing. So let's see stride. What is stride? So let's copy, paste. Now stride is used to skip certain characters from a string. If I want to print string of, let's say I want to print whole string, so I will use colon here, and the another colon is used to specify the stride. So this is starting of the string. Let's say I want to start from 0, I want to end at 10 element, and this here we have to specify stride. So stride is used to skip some element, so I want to skip every second element, so I will get alternate numbers from a string. When I run the string, I got every alternate number up to 10. If I remove this number, this means I want to start from 0 and include all the string. So when I run the code, I will get whole string, but uh, except alternating characters. This is how we can use the stride. We can also specify negative numbers, like say I want to specify -1, then it means I want to start from the last element to the first element. When I run the code, I got the whole string in reverse. Let's say from I want to start from 8, then end up to 1, and I want to reverse it. So I got the reverse of starting from 8 to 1. This is how we can use stride. So this is all about indexing, slicing, and stride in Python. We will be learning some of the built-in functions provided by Python to manipulate strings. Let's create a new file, name it string functions. To see all the functions of the string, we have help method where we can see help with strings in it and run the code. You can see all the functions of the strings are shown here. We can also see the same with list. You can see all the functions are shown here. Now how to concat two strings in Python? Let us declare string1 of first name and give first name, let's say Henry, and last name, give it value for. Now if I want to concat these two strings, let's say the string name is first name, I have to use just a plus sign and last name, and when I print the name, you can see Henry Ford is printed. But if I want to add a space to here, I can just use another plus sign and add a space and run the code. You can see the space has been added. So this is how we can concat two strings in Python. I can also concat multiple strings using this. So plus, and if I want to concat is a good businessman and run the code, you can see the string has been added to the previous string. So how to use for loop with the strings? So if I have the string name Henry and I want to access is character of Henry, so I can use for loop. So for character in first name, and print the character and run the code. You can see all the characters has been printed to the console. If I want to manipulate this character, let's say I want to add every character with star and print them in the same line. So we have end method in a print and run the code. I can see the star has been added to every letter and they are printed on a same line. Now if I want to print the first name and last name of a person by using these variables that we have declared earlier, the first name and last name. So I have to use print statement, then first name, then colon, and I have to use plus sign and first name, our variable, and then again the plus sign, then I have to add the space, then I have to add again plus sign and again last name, colon, and again last name, and run the code. So this is how we will get the output, but this is very lengthy process. I have to use plus sign many times, and this is also not optimized for Python. So there is another method to write this. I have to use print statement, then I can use f string over here, and I can write first name, and when I have to write the variable, I can use curly brackets and give the variable name here, and again last name, and again curly brackets and the variable name, and we don't have to use the plus sign again and again, and it is also optimized for the Python, and we can run the code. You can see that we have got the same output, but we don't have to use the plus sign again and again. Then there is also a format method which is very similar to the f string. Let's see how to use it. Print. I can use first name, colon, and I can use curly brackets here, and last name, and give curly brackets, and here I can give dot format and first name, comma, last name. So this is how we can pass the values to it. And if I want to print the first name in a first column, I will write 0 here and 1 here and run the code. I can get the same output, Henry and Ford. But by using format method, I can exchange the value just by changing here 1 and here 0 and run the code. You can see here is Ford and here is Henry. So by using format method, I can decide it later what variables I have to add. Let's see, I have a string str and it has value. This is a Python string. So if I want this letter to be capital, so in English, the first letter of the sentence must be capital. So the capitalize method is used to do the same. It will capitalize the first letter of the string. Let's see it in action. I want to print str dot capitalize and run the code. So I got the string in the console with the first letter as capital. So str.capitalize will return me a new string and it will not change the old string. So if I print the old string, I will get the same string here. So I can store this string into a new variable. Let's say capitalized string is this and print capitalized string. run the code, I will get the same output. So this is how we can capitalize the string. Now let's see some more function of a strings. So if I want to make every character of a string capital, so I can use upper method. Let create a new string. Upper method will also return a new string. So let's store it in another variable named of string and call the method upper and print upper and run the code. You can see this has been printed. Then so lower works similar to upper. So let's create a variable named low string and call the method lower and print low string variable, and you can see the string has been converted to the lowercase. If I want to create a title of a string, so in a title every first character of a string is uppercase, so title is used to do the same thing. So let create a new variable and string dot title. Let's call the function and print the title string and run the code. So here we can see the first character of uh, every word is uppercase. So this is how we can use the title string. So along with this method, we have is upper, is lower, and is title method. So this method are used to check whether the strings are in a lowercase or whether it is a title string or whether it is a uppercase string. So let's see how to use them. This method will return me a boolean value, so it will be either true or false. So let's see string dot is upper, so our string is not in uppercase, so I will run the code. You can see it is false, but the up string is uppercase, so I will write that here and run the code. You can see it has written me true. Now similarly we will check is lower and run the code. Similarly, I will use is lower with uppercase string. So I will and run the code. I will get false. And if I run with the lowercase string and run the code, I will get it as a true. Similarly, I can print title string dot is title and run the code. I will get true. And when I run it with the normal string and run the code, it will give me a false value. So this is how we can use is upper, is lower, and is title. Split is used to convert the string into a list. So split will split the string with respect to the character we have passed. So let's see it in action. I want to create a list of words. So I will use string.split and I will pass a character of space. So every word will be split into the list and I will print the list and run the code. You can see the list has been created with every word because I have split it with the space. If I want to split the string with, let's say, s, then at every s the string will be split. So you can see the string has split with s, then is, and so on. Let's do it with space again and run the code. Then there is a join method. Join method will convert the list of words into the string again. So how to use join? I have to specify what character I want to join with. Let's say I want to join the string with the dashes. Then I have to specify the name of method, which is join, and I have to pass the list which is the list of words. So the list is now joined. So let us give it a name, join string, and print it and run the code. You can see our list has been joined with the dashes. If I want to join it with the spaces, I can use space here and run the code. You can see here it is joined with spaces. I can use any character that I want. If I want to use star here, I can see the star has been printed by joining the string. So this is how we can use join method. Now we have find method. Find method is used to find index of particular word we want to find. Let's copy our string. And if I want to find the index of the character A, then I will use string dot find. Then I will pass the character A, print it, run the code. You can see it has been printed to our console. Similarly, if I want to print the index of is and run the code, so it is at second place because it will see the first is it will find this will find this is and it is at 0, 1 and 2 location, so it will give me 2 back. The find will find the very first word it will find in a string. So let us find Python and run the code. It is at 10th place. Let's count the characters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10th word is Python. So this is how find works. Now let us see how strip, lstrip and rstrip works. So if I have the string with a lot of white spaces in it, I will add some spaces and I want to clear them out. Then strip, lstrip and rstrip can be used here. Let us print string dot strip and run the code. I can get the string with no white spaces in it, and if I print the string itself and run the code, I can see the white spaces are also printed in the console. And when I use the strip method, they are just gone. So similarly, lstrip will remove the white spaces from the left side, and the right hand side also has the still has the white spaces, and rstrip will remove the white spaces from the only right side, and left side still have the white spaces. Then replace is used to replace certain part of string with something else. So let us replace uh, the is from this string with capital is. So how to do that? I will create a new string and use string dot replace. I want to replace is, so I will write the first character is, and I will pass a new thing which is capital is here, and print the new string and run the code. I can see the is has been replaced with the capital is, and this is also has been replaced. So replace will replace all the matches of the word it will find in the string. So let's say I want to replace Python with JavaScript and run the code. I can see here JavaScript has been added instead of Python. So this is how we can use a replace function. So this is all about built-in functions provided us by Python for string manipulation. We will be learning list. Let us create a new file, name it list. To initialize list in Python, we have to use square brackets. Let us initialize the list of numbers. I will give it a name num. initialize it with square brackets and add some numbers to it. Now the lists are mutable, which means we can add element, update the existing element and delete the elements from the list. Now let us see it in action. Let us print the list first, run the code. You can see the list has been printed to our console. Now let us add some element to the list. We have to use append method to add some elements to the list. Let us add 90 to our list. Let us copy the print statement and print the list again and run the code. You can see 90 has been added to our list. Now let us update some elements from the list. In order to update the element, we have to give specific location which element we have to update. Now the list has indexes which starts from 0. So the index of 1 is 0, the index of 2 is 1, index of 3 is 2, index of 4 is 3, and so on. So if I want to update 1, I have to use the indexes. So I will use, let's say, num of 0. I have to use square brackets in order to know Python that I am accessing the first element of the list, and I will give it a new value, let's say 11, and print the list again. And when I run the code, you can see 11 has been updated instead of 1. If I want to print num of 0, I can use the same syntax, num square bracket, and add 0 to there, and I can see the 0th index element, that is 11, has been printed. If I want to access the second element, that is at index 1, I will use 1 here and run the code. So 2 has been printed. So in this way we can access the elements and also update. Now if I want to access the last element from the list, I can use negative indexes. So list in Python has two types of indexes. First one are the positive that we have seen. Then let's say negative indexes. So in negative indexes start from -1. As the positive indexes start from 0, negative will start from -1. So the -1 index will be the last element. Then -2 will be the last second, that is 6, and so on. If I want to print the last element from the list, I will use print, give the name of the list, square brackets, and use -1. And when I run the code, I will get 90 because we have appended 90 at the last of our list. If I comment it out and run the code, I will get 7 because we haven't added 90, so it will give 7 to me. Let's uncomment our code and run it. I will get 90. Similarly, if I use -2 and run the code, I will get 7 because 90 is added here and 7 is at -2. So this is how we can access the negative indexes. And if I want to update it, let's say if I want to update num of -2 to, let's say, 22, and print the list and run code, I will get 22 at the place of 6. So this is how we can update the list. Now let's see delete. Now to delete certain element from the list, we have pop method. So let us copy our list here and see it in action. If I use num.pop, by default it will remove the last element from the list, and when I print the list again and run the code, you can see the 7 has been removed from the list. The pop element also returns the number that has been removed. So if I want to print what has been removed, I can use print and run the code. I can see 7 has been printed, that is 7 has been removed, and you can see the 7 has been removed from the list. I can also assign it to some value. Let's say remove is equals to num.pop, and if I print rem, and run the code, you can see 7 has been printed. So this is how we can remove the element and access the element which has been removed. Now let us see how to remove the element at particular index. So say if I want to remove 2, so index of the 2 is 1, as index start from 0. 0th index is has been given to 1 and 1 index has been given to 2. Num dot pop, and I will give the index 1 and print num and run the code. You can see 2 has been removed from the list. This is how we can remove at particular location. Now if I know what element to be removed but I don't know the index of it, then we have remove method. To use remove, give the use the name of the list, then dot remove, and what element I want to remove I can specify here. Let's say I want to remove the 6 and print the list again. Run the code. You can see 6 has been removed. Now the Python will see the first index of this where it find the 6, and it will remove the first 6 it will find. It will not check the another 6. If I want to remove that 6 also, I can copy the code, run it once again, and run the code. You can see both of the 6 are removed. So when I remove something at one time, it will remove only one element. Even if there exists more than one element, it will remove only one. So this is how we can use remove. And if I want to clear all the elements from the list, there is a method named clear. Let's say it in action. If I use num.clear and print the num and run the code, you can see all the elements from the list has been removed. So this is how we can delete the element. Now if I want to delete the list itself, then there is keyword named del, and I can give the name of the list which I want to delete. If I try to access it, I will get an error because I have deleted num. Now I cannot access it. If I comment that out and run it again, I can access it again. So this is how we can delete the list. If I want to remove a certain element from the list, we have remove method. If I want to pop element from particular index, I can use pop. By default, pop removes the element from last location. And if I want to update the element at particular index, so I can use indexes in square bracket and write the new value by using equals to sign. Now list is a ordered data type. So any data type which is ordered in Python, we can use indexing, slicing, and stride over that. Let us declare the list name L and give it a value 900, 800, 700, 600. Now indexing is used to access certain element from the list. Let's say L of 0 and print it. You can see 900 has been printed. If I want to print the last element, I can use -1 and last element has been printed. So Python has two types of indexes. The first one starts from 0, 1, 2, and so on, and the last element start from -1, -2, -3, and so on. So this is how we can access the element from the list. So this is called indexing. Now let's see slicing. If I want to access particular portion from the list, I can use slicing. Let's say I want to access from an element 900 to 700. So I will give L of 0 colon. Colon is used to separate the two indexes. Let's say I want to access the element up to 700. So I will give 3 over here because the index of 900 start from 0, then 800 to 1, 700 to 2, but by default Python exclude the last element. So we have to give 3 over here, and when we print the list we can see 900, 800 and 700. So it will print 0th index, 1 index and 2 index. So this is how we can use slicing. If I want to access the element from 800 to 600, then how can we use the slicing? Let's say print l of l, then square brackets, then I will give the index of 800, which is a 1. Then I will calculate from 800, that is 1, then 2, then 3, and by default Python exclude third element, so I will give here 4 and run the code. I will get 800, 700 and 600. Now let's see how to use stride. So stride is used to skip certain element while we are accessing using slicing. If I want to access from 0 to the 4th index, I will write print l of 0 colon 4. Then I want to use the stride, then I will give 1 colon again, and I will specify how much element I want to skip. So I will skip every second element, therefore I will write 2 here, and uh, run the code. You can see every second element is skipped. So by from 0 to 4, that means we want to print all the list but skipping the every second element. So 800 is skipped, the second element, and then 600 is skipped, so I will get 900 and 700. So this is how we can use stride. Now in list we can use heterogeneous data types, which means we can add anything to the list regardless of its data type. Let's initialize a list with value 1, 2, 3. Now I can add string to it, let's say Python. Now I can add list inside a list, let's say list with value 99, 88 and 77. If I want to add tuple inside a list, I can use square brackets to initialize a tuple and add some values to it like 1, 1, 2, 2 and 3, 3. This is how we can add any data types to our list. List support heterogeneous data types. If I want to access certain elements, we can use indexing. Let's print certain values from a list. Let's see the first value, which is 1. Let's run the code. The 1 has been printed. Now if I want to print Python, it is at third index. Let's run the code. I can get Python here. So if I want to print the element inside a list, so the list is present at fourth index. Then if I want to print 99, then the index of 99 is 0, which I can specify by writing another square bracket and specifying 0 over here and run the code. I can get 99. If I want to get 88, then I can use index 1 and run the code. If I want to access indexes inside a tuple, I can use the same syntax. Let's say the index of the tuple is 5. I will give here 5, and I want to access, let's say 33. So index of 33 is 2 and run the code. I will get 33 here. So this is how we can access list inside a list or tuple inside a list by using another square bracket. Let's see how to use for loop over a list. So if I want to iterate over each of the element from a list, I can use for loop. So for value in L. So this is the name of list I have specified. So this value will return each value of the list starting from the index 0. Let's print the value, print val, and run the code. You can see every value has been printed starting from 1, 2, 3, then Python and the list and tuple. So this is how we can access each value in Python using for loop. Then append method we have seen to add extra elements to the list. If you want to add 900 to our list and print the list and run the code, you can see 900 has been added. Now if I want to add multiple element in the list at one time, Then I can use extend method. Let's see extend in action. If I want to add 900, then 800, 700, 600 to the list at the same time, then I can use extend and print the list and run our code. You can see all the element has been added at the last. So this is how we can use extend method. If I want to use append to add multiple elements, let's see append, and I will add 998877 and print L and run the code. You can see this another list has been added to our existing list. Using append, the list has been created inside a list. If you want to add without creating list inside a list, we can use extend method. If I want to make a copy of a list, let's create a copy name L2 and from our list L and print L2. So the L2 has been created, and uh, so this is how we have created another list name. If I want to copy our list, so how can we do that? Let's create another list L2 and point it to L1 and print L2. Run the code. So L2 has been printed. If I have removed certain element from a list, let's say I pop the last element and run the code, the last element from L2 has also been removed. If I comment this out and run the code, there was a list at the last, and if I run the code again, you can see the last element has been removed from L2 also. So this is not actual copy of a list, but this L2 is pointing to the same list. So to create a real copy of a list, I can use, let's create L3, and I can use L dot copy method. So let's print L3 and run the code. So L3 has been created with respect to L. So if I have removed certain element, let's say I want to pop the last element, that is 600, and print the original list, and I want to print the newly created L3 and L3 and run the code. You can see the 600 has been removed from the original list, that is L, but from L3 the 600 is present over there. So to create a real copy of a list, we can use copy method, and to point another list to our original list, we can use equals to sign. So this by this the new list will point to old list. We will be learning tuples. Let us go to our Pycharm window, create a new file, name it tuples. Now in Python, to initialize tuple, we have to use round brackets. Let initialize a tuple of numbers, name it tup numbers, and initialize it with round brackets and add some numbers to it. Now help function will give you all the functions which are available in Python with respect to tuples. Let's run the code. But you can see only count and index function is there. Therefore, tuples are immutable objects and we cannot add any value to it, or we cannot change any value inside a tuple. Therefore, tuple are immutable objects. Let's try to do that. If I try to append, let's say 90 to it and run the code, you can see I got an error saying there is no attribute of append in tuples. So we cannot change the values in tuple. Let's say let's try to update values in tuple. The name of tuple is tupnum, and I will try to update the 0th index value and give it value 11 and try to do that, and I will again get an error. So this is how tuple are immutable objects. Here I will write we cannot update or modify tuple. Now tuple is an ordered object, which means we can apply indexing, slicing and stride over the tuple. Let's see it in action. So the index in tuple also start from 0. So let's try to access 0th index. Print that, run the code. You can see 1 has been printed to the console. Let's try to print the third element, and I got the 4, that is 0, 1, 2 and third element is 4. So this is how we can use indexing. Now see how to use slicing. So if I want to print from index 0 to third element and run the code, I will get 1, 2 and 3. Similarly, if I want to print from 3 and 4th index and run the code, I will get only one value, that is 4. So this is how we can use slicing. Now let's see how to use stride. As we know, stride is used to skip element while we are accessing them. Let's try to do that. I will use square brackets. I will access element from index 0 to index 4 and I will skip every second element and run the code. I got 1 and 3. This is because I will got 1, then 2 is skipped, then I will got 3 and 4 is skipped. So this is how I got the answer. If I want to access all the element and skip every second element, then I will not write anything at this place and run the code. I will get all the element except every second value. So this is how we can use striding. Now tuple also support heterogeneous data types. So let's declare a tuple hetero and add some numbers to it, then add some strings, add a tuple inside tuple of some values 99, 88, 77 and a list of values 0, 0, 1, 1, 2, 2. So this is how we can use any data type inside a tuple. Therefore tuple supports heterogeneous data types. Let's print tuple hetero and run the code. You can see the tuple has been printed. So how to use for loop with the tuple? It is very similar to the list. We have to write for value in and the name of tuple, that is tuple num, and I can manipulate the value or just print and run the code. You can see all the numbers has been printed from the tuple as I am accessing this tuple. So this is how we can access values from the tuple using for loop. So how to use count function in tuple? Let's say I have multiple 1 and I want to count how many ones are present in a tuple. So I will use tuple num dot count and the value I want to count, that is 1, and run the code. I will get 3 as an output. If I want to count number of 2's and run the code, the 2 are present 2 times in the tuple. Similarly, 3 is present only 1 time, therefore it will give me 1. And if I want to check the index of certain element, I can use the index method, that is tuple num dot index and index of, let's say 3, and run the code. So index of 3 is 5. We can count that 0, 1, 2, 3, 4 and 5. Fifth number is 3. So this is how we get 3. And if I try to get index of 2 and run the code, it is 1 because 0 is 1 and one index is 2. It will get only the index of first element it will find, and it will not get the index of the another element. So this is how we can check the index of certain elements in tuple. Now let's see how to convert list to tuple or tuple to list. Let's say I have a tuple. Let's copy our previous tuple, and I want to convert this tuple into list. So how can I do that? So I will name it. List tuple. I have to use list method and pass it the tuple. Our tuple is tuple num, and print list tuple and run the code. You can see I got the list. I can also check the type of our list tuple and run the code. You can see it is of class list. I can also convert this list into tuple again by using the tuple method. Let's see. Let's name it tuple list and use tuple method and pass it our list and print our tuple list and run the code. You can see we got the tuple, and to see the type I can use type method and pass our tuple list and run the code. You can see it is of type tuple. So this is how we can convert tuple into list or list into tuple. So this is all about tuple. We will learn how to use dictionaries. Let us create a new file, name it dictionary. Now dictionary in Python have key value pairs, and dictionary is initialized by using curly brackets. Let us initialize a dictionary of square numbers. Let's give it a name sq num and initialize it with curly brackets, and I will give 1 square is 1, then 2 square is 4, then 3 square is 9, and so on. So keys in dictionary are immutable, that is we can only use integer, float, string and tuple for initializing keys in dictionary. But for values we can use any data type for the values, that is I can add any number like 1.1 colon and any value to it like 4.4, or I can use the value of string, let's say list and lst and list 1 2 3, and also I can use tuple and a tuple for a key like 1 2 3 and give it a value of string like str. This is how we can initialize a dictionary in Python. So let us clear some values and print our dictionary, run the code. You can see our dictionary has been printed to our console. Now dictionary in Python is mutable, so we can add, update and delete elements from dictionary. So let us see how to add element in a dictionary. Now if I want to add 4 and its square which is 16 to this dictionary, to add values in a dictionary I have to use the name of our dictionary. I have to use square bracket. To specify key I have to specify key in a square bracket and give it the value by using equals to sign. Now key with 4 is added with a value 16 to our dictionary. Now if I print our dictionary and run the code, now we can see key 4 with value 16 has been added to our dictionary. Now if I want to update the value, I can use same method, that is square num, and in square bracket I have to specify which key I want to update, like for example, if I want to update 1 and give it a value 101 and print our dictionary and run the code, you can see 1 is updated with 101. Similarly, if I try to update the 4 with, let's say, 32 and run the code, I can see 4 is updated with 32. So this is how we can update the values in a dictionary. Now to delete value, we have multiple methods. Let's say them one by one. Let's see first pop method. Using pop method, I can specify which element I want to delete. Let's say it in action, pop, and I want to pop the element of key 2, and now I want to print the dictionary and run the code. You can see key and value pair of 2 has been deleted from the dictionary. The pop method also returns the value. So if I save that value to the variable re, and if I try to print re and run the code, it will return me the value which has been deleted, that is 4. Now let's see pop item method. Pop item method will pop any random element from the dictionary. Let's say square num dot pop item. It will pop random item from dictionary, and if I print square num and run the code, you can see the last item has been deleted. Now let us see how to delete using del method. So by using del method, I can delete just by writing del and square num, and in square bracket I have to specify which key I want to delete. So we have 1 available and 3 9 available. So if I want to delete 3, I can specify 3 in square bracket, and let us print our dictionary, which is square num, and run the code. You can see 3 9 has been deleted from our dictionary. So so let us comment this out for a minute. So we have 2 elements, and if I want to delete all the element at once, we have clear method. To use clear method, I have to use the name of our dictionary, and using dot I have to mention the clear method. And when I print the dictionary now and run the code, I can see all the element from the dictionary has been deleted. So this is how we can use clear method. And also I can use delete method to delete whole dictionary at once. Let us see that. Delete to, I can use delete keyword and specify the name of dictionary, which is square number. And now if I would try to access square number and run the code, I will get an error because I have deleted our dictionary. If I comment that out and run the code, I can say the dictionary is present. So delete is used to delete the square number from existence. So let us copy our code here. So list is an unordered data type, that is we don't have indexes like list, tuple, or string. Now how to access keys, values, and items from dictionary. So if I want to print only keys, so square num, and we have keys method which will return me all the keys. I will comment this code out and run the code. I can see all the keys has been printed in a dictionary. Similarly, if I want to access all the values, I can use name of dictionary and use the method values and run the code. I will get all the values. Similarly, if I want to get all the items from a dictionary, I have items method. Let us print square num dot items and print. I will get 1 and 1, that is the first key and value pair, then second key and value, that is 2 and 4, and third key and value, that is 3 and 9. So this is how we can use items method. Now let us see how to use for loop with the dictionary. I have to use for, then value in, and I have to specify the name of dictionary, that is sqnum, and print value. So this value will return me all the keys from the dictionary. When I run the code, I will get all the keys, that is 1, 2 and 3. 1, 2 and 3. If I want to get all the values, then I have to specify for value in sq num dot val and print value. Now, as I have used values over here, so this value will return me all the values from a dictionary and run the code. So I will get 1, 4 and 9, that is 1 and the 4 and 9. So this is how we can use values. If I want to access key and value at once using for loop, then I can use for key comma value in name of our dictionary sqnum dot items. And when I try to print k and v and run the code, you can see all the keys and values has been printed. So key 1 has value 1, key 2 has value 4 and key 3 has value 9, as we can see here. So this is how we can use for loop with dictionary. We'll be learning about sets. Now let us go to our Pycharm window and create a new file named sets. Now to initialize set, we have to use curly bracket. For example, if I want to initialize a set of numbers, then I have to use curly brackets and add some numbers to it. And if I print these numbers and run the code, you can see our set is created. You can also see the type of nums and run the code. You can see it is a type of set. The set contains only unique element. Now to validate this, if I want to add multiple 4s to our set and run the code, you can see only one 4 is there. Let us see if I add multiple zeros to our set, what happens. And run the code. You can see only one 0 has been added to our set. Now sets stored elements in unordered fashion, which means we cannot have indexing or slicing in sets, which means the elements are stored in random order as like in a dictionary. So if I try to print nums of 0 and run the code, it will give me an error because indexing is not supported in set. Now how to initialize an empty set? For example, if I initialize the set of employees and assign empty curly braces to it, and then we know that dictionary is also initialized by using empty curly brackets, so Python will assign this as a dictionary. You can also check print type of employee and run the code. You can see it is a type of dictionary. So how to initialize an empty set? I will write m equals to, and we will use the function set. And if I try to print, now if I try to print type of employee and run the code, I can see it is a now set. So sets are mutable objects, which means we can add, update or delete elements from the set. So to add element in employee, for example, if I want to add some name of employees, I have add method, and let's say I want to add John, then I will copy it multiple times and add again Walter, and let's say Harry. And if I print, I can see the list of the set of employee has been printed. Now if I try to add John again to our set and run the code, you can see John has only once added. Now updating in a set is quite different. Let's say I have another set to a set of employee 1. So we have these two sets now with name emp and emp1. So if I want to update emp with emp1, I will write emp update and emp1. Now if I want to print emp and run the code, you can see the emp has been updated with the values of emp1. Similarly, we can delete certain elements from our set. So we have pop method. If I use pop method, so pop will remove any random element from set, and it will also return. So I can store the result in, let's say, result, and when I print emp1 and run the code, you can see emp2 has been removed. So this is how pop removes any random element. So we have remove method. Remove method will remove only the element which we have specified. Let's see it in action. If I want to remove John from emp, I will write John here, and when I print emp and run the code, you can see John has been removed and others are still present in our set. Now if I want to delete all the element of our set, we have clear method. If I specify m.clear and print m and run the code, you can see the set is clear and I am getting an empty set. Let us comment this out, and then we have del method. Del method will delete our set, and when I try to access it again, let's say I want to print it again after deleting, I will get an error. So when I comment it out and run the code, it will run without an error. So del method is used to delete our set entirely. As similar to dictionary, we can only add immutable elements to our set. Let us declare a set of let us declare a temporary set, and we can add immutable elements such as string or integer or float or tuple. So if I print temp, run the code, you can see the temp has been printed. But if I try to add some mutable element like list and run the code, it will give me an error because list is an mutable element and set does not support mutable element. So how to use for loop with sets? We can declare for element in set. For our example, it is temp, and when I try to print and run the code, so we can see all the element has been printed to our console. We have many built-in function for sets. The add we have seen to add element. Now let us see. We have set s1 with element 1, 2 and 3, and set s2 with element 1 and 4. Now the union function will return another set let's say it has S3. If I want a union of S1 and S2, S1 union S2, and when I print S3 on the console and run the code, you can see we have got the union of the two set. Similarly, we can find intersection and run the code. So only one common element is there, so we got only one over here as an intersection. So similarly, we have difference function. So difference will return me a difference between S1 and S2. When I run the code, it will take all the uncommon element from S1 and return me. If I write S2 over here and S1 over here and run the code, so it will return me all the uncommon element from S2. So this is how difference works. So each superset is used to check if S1 is superset of S2 or not. Let us see it in action. So in this case, S1 is superset of S2. Let us check it. Is superset and run the code. So it will return me a boolean value which is true. If I check it is a subset or not, then it will tell me it is a false because S1 is not a subset of S2. If I reverse S2 and S1 here and run the code, it will give me true because S2 is a subset of S1. So there are many more methods with respect to set available. You can check on your own pace. Welcome to this chapter. This chapter is continuation of fourth chapter. Here we will see list, tuple, dictionary and set in detail and what are the functions provided by Python to us. Let's create a new file, name it data type, and let's learn each of them in detail. Let's start with the list. Uh, let's initialize the list of numbers. I will give it a name, number list, and add some random numbers to it. Okay, that's enough for our example. Now we will see the sort function which is provided by Python to us. Now if I want to print the list, I can just write number list. This we have seen in previous lectures also. So the list is printed in the console. Now let's see how the sort works. Then if you want to sort these numbers, then we will use sort. First write the name of the list, number list dot sort, and the list is not sorted. Now just we have to print the list. We will print it again, then we will see the list is now in a sorted order. If you want to sort it in a reverse, then we have to just specify reverse is true, and when we run it, we will see the numbers are sorted in reverse order. We can also specify reverse is false if you want to sort in ascending order. So in ascending order, but this is optional. So if we don't specify it, we will still get in ascending order. If we want the descending order, we have to specify reverse is true, then we will get the descending order here. So let's see the append method. By using append, we can add some numbers to our existing list. So let's say 888. Then we can give number list dot append 888 to it. Number list dot append and 888. When I print the number list again and run the code, I will get 888 added. Now extend method works similar to the append, but by using extend we can add multiple numbers to it. For example, number list dot append, dot extend, and we can specify a list in here with the numbers we want to add. Let's add 777, then 666, then 555, and then print the list. We can see the sub list is added to this list. We will move to our next function, which is min and max functions. So to get minimum from the list, we can just use min function. Min number is minimum of the number list, and I can print min number and I will get the output as 1. And when I add 0 to our list, what will be the min number? Of course 0. Then to get max number, is max of number list and print max of number. So we will get 888. As we can see, 888 is the maximum number of our list. So this is how we can use minimum and maximum function. Just write maximum, use round brackets and specify the list, we will get minimum, and use max function, specify the round brackets and add the list, and we will get the maximum number. If you directly want to print the maximum number, we can remove this function and use max of number list. This will also work the same way. Instead of storing that number into the another variable, we are directly printing that to our console. If you want to find the length of the list, then we have variable named len. So len of number list. So print length of list and run the code. We have 16 elements in here. To access each element of the list, we can use number list, and we can specify which number we want to access. If I want to access 0th element, I can specify 0 in here, and I will just comment some print statement and run the code. I can say 0th number is 9. So index starts from 0th place. If I want to see the third number, so 0 will be 9, 1 will be 7, 2 will be 6, and 3 will be 5. When I run the code, so I will get 5 in here. So this is how we can access the numbers from a list. To count a specific number, we have to use count variable by using count, and what I have to count in here. So if I want to count 1, then I can specify 1 in here and print count and sum of number and run the code. I will get the number of 1 in a list is 1. If I add more 1 in a list, I will add 3 ones and run the code. I will get 3 1, and sum of the list is 2933. So this is how we can find the count. So this is it about the list. Now we move to tuple. Let's define a tuple. I will copy the same numbers number and I will change the name to tuple, and I will change the square brackets to the round brackets. So our tuple is ready. I will write all the functions and get back to you. Now I have specified all the basic functionalities of tuple. I will run the code, such as the sum of tuple is 47, then the maximum of them is 9, then minimum of them is 0, and the length of tuple is 14. If I remove some elements from tuple, you can see there are 4 elements. I can run them again. So there are 4 elements, minimum of 0, max is 9, and the sum is 17. So this is how we can work with tuple. To see the sorted function will return a new tuple. We have to store it in a new variable. So new tuple equals to, and run the code. We will get the sorted list. So it return us a new list, but if you want to convert it into a tuple, we can typecast it by using tuple on the start. So we get a sorted tuple by using this. But the old tuple is not modified. We have got a new tuple by using sorted function. So if I want to print the number list, number tuple, and run the code, the old tuple is in the same way. Remember, when we use sorted function with the list, we get the modified list. But when we use the sorted function with the tuple, we get a new tuple, and the old tuple remain the same. Let's discuss about dictionary now. So I have defined a simple dictionary in here which contains the number and its spelling. So 1, 2 and 3, 4. So I have printed the dictionary. Then with item I will get all the item in a dictionary. With keys I will get only the keys. Keys are 1, 2 and 3, and values are values are the spelling of them. So I will get values in here. When I run the code, you can see in the first line I have get the dictionary. In the second I got the items in the form of tuples, like 1 with its spelling, 2 with its spelling, 3 spelling, and so on. With keys I have got the list with the keys, and with values I got the values in here. So this is how we can work with dictionary. Then we will start with set. I will initialize a set of numbers with curly braces, and I will add some numbers to it. Let us define another set. Now we have defined the two sets. Let's print them. Print set1 and print set2. Run the code. We will get the set in our console. Let's add some element to the first set. Then we can use add function over there. So set num1 dot add. Let's say we want to add 12 to it, and then print the set1 again. Run the code. We can see the 12 is added at the end. So to find intersection of these two, intersection will give us common element of these two sets. That's why we have defined two sets. So set num1 dot intersection and set num2, and I want to print this print statement, and when I run the code I will get only common values between these two sets, that is num1 and num2 has and 1 2, then 4 and 5 common, so 4 and 5. So this is how intersection works. Then we can print set num1. If it is a superset, is superset of set num2, we can print it. It will give us a boolean value which will be either true or false. True or false. So superset, it will return true if all the numbers of set1 will be in set2. So this is the superset. Then subset, If it is a subset, it will also give us true or false. Is subset, then it is also false. Move some numbers from here, so and add 3. So all the numbers in set 2 is belongs from set 1. So let us run. Then so all the numbers from set number 2 belongs to set number 1, so that give us true, and if it is a subset, then we get a false. Arithmetic operators. Let us go to our Pycharm window, create a new file. Arithmetic operators. Let's copy our points what we are going to learn. Now Python provides us addition, subtraction, multiplication, division, and exponential operators. There are also modulus and floor division. Now let us see all of them in action. So let us define some numbers. Let's say num1 is 10 and num2 is 20. So plus is used for addition in Python. So if I want to print num1 plus num2 and run the program, I will get 30 as output. Similarly, if I want to save the sum in sum1 variable, I can use num1 plus num2, and if I want to print the sum1 in the console and run the program, I will get the same result. Now let us move to subtraction. In subtraction, we use dash sign or minus sign, so we can directly print subtraction using num1 minus num2 and run the program. I will get minus 10 because 20 is greater than 10. If I use the reverse of it and run the program, I will get positive of the value. Then multiplication, asterisk or star is used for multiplication. If I want to print multiplication of num1 and num2, I can use num1 star num2 and run the program. I will get 200 as output. Then there is a division. So for division, we use slash. It is a backward slash, not the forward. We also have the forward slash on our keyboard. So this is the one, but we don't have to use it. We have to use the backward slash. So if I want to print the answer, which is num1 slash num2 and run the program, I will get 0.5. In many of other languages, we will get 0 as the answer. This is because the answer is in a float, and normally by default compiler used to compile and give the integer as the answer. So that's why we have to define it as a decimal or the float number, and then we have to print in other. But Python give us 0.5 by default. That's why uh, Python give us a real result. If I want to give integer as an output, I can use floor division here. Then I can use num1 double slash num2. Remember, we have to use double slash for floor division, and when we run the program, I will get 0. So this is how we get floor division. Now there is a modulus operator. Modulus operator gives us the reminder of the division. So let us see some answers. Uh, let's say if I divide num1 by 2, I will print it num1 mod 2. I will get the answer as 0 because when I divide num1 by 2, I will get 5 as a 5 as a answer and 2 as a 0 as a reminder because 10 is completely divided by 2. If I give some non-divisible number such as 3, as 10 is not divisible by 3, when I run the program, I will get 1. Here it is the result. I will comment this out for a minute and we can see we are getting 3 because we are getting 3 multiplied by 3 is 9 and remainder is 1. We are dividing 10 with 3, so the answer is 3 and remainder is 1. So modulus provides us a reminder, so the remainder is 3. For another example, we can use 100 and we will still get the same answer. If I use 9 over here, 9 is completely divisible by 3, so I will get 0. So this is the use case of modulus. For exponential, if I want to find the power of some variable, I can use double star over there. If I want to print 100's square, I can use 100 to the power of 2 and get that result as 10,000. Similarly, for a simple number like 3, if I run the code, I will get 9 as an answer. And lastly, the floor division will give 0 as the answer. Here we will see comparison operator and logical operators. Now let us copy the points. I will comment out the whole code and continue in the same file. I will paste those points here. Then the comparison operator mainly give us the boolean output, which will be either true or false. So we have equal, not equal, greater than, less than, greater than or equal to, or less than or equal to operators available in Python. So if I want to print 1 is equals to 2, then it will give me output as false, as you can see it in the console. So equal to operator is used to compare two values and give result as an output as a true or false. So if I want to compare 1 with 1, so it will give me a true. Then there is a not equal operator. If I want to print 1 is not equals to 1, I will comment the first code out and print it. So it is false because 1 is equals to 1. And if I use equals to in here, it will give me true. And if I use 1 is not equals to true, then it will give me true because 1 is not equals to true. So similarly, greater than, I will use 1 is greater than 2 and print the output, I will get the value as false. And if I reverse the condition, that is 2 is greater than 1, and run the code, it will give me true. So as 2 is greater than 1. So let's see less than. So 1 is less than 2. It is a true condition, so it will give me true. And is 2 is less than 1, it is false, so it will give me false. Now we will understand greater than or equal to operator. So let's see the example. If 1 is greater than or equals to 2, and another example, print 1 is greater than or equals to 1. When I run the code, I will get false in first condition and true in second condition. So how the greater than or equals to operator work is, if any of the condition is satisfied, that is greater than or equals to, it will give me true. That is, if 1 is greater than 1 or 1 is equals to 1, any one of this condition is satisfied, it will return me true. If both of the conditions are false, then it will give me false. Here you can see both of the conditions are false. Is 1 is greater than 2? No. And 1 is equals to 2? It is also false. So the overall answer is false. And here it is true. So it will see overall answer with OR condition. Any of the condition is true, it will return me the true. Similarly, less than or equals to works. We will use the same example and change the signs. It will give me true in both cases, because 1 is less than true is true and 1 is equals to true is false, but one of the condition is true, therefore the answer will be true. And 1 is less than true, 1 is less than 1 is false, but 1 is equals to 1 is true, therefore overall answer will be 1. So this is how less than or equals to work. And let's see logical operators. Comment out the initial code, and okay, so for let's say and, now and will return if both the statements are true. So I will print statement 1 is let's see the simple example first. Let's say statement 1 is true. I will directly use the values as true or false. So true and false. So one of the statement is true and another statement is false. Therefore overall answer will be false, because it will return true only if the both of the statement are true. Let's say if I change it to true and run the code, I will get it as true. If I change the first statement as false, it will again turn out to be false. So both of the condition needed to be true to get the answer as true. I will write it out. So print true and false, it will give me false. Print true and true, it will give me true. Then print false and false, it will give me false. You can see only one condition is true, that is if both of the statements are true. Other all will be 0 or false. So we will see or. For example, if any of the statement is true, I will get the answer as true. True or true will be true. Okay, so let us copy the same statement over here. It will be easy to understand. And I will change all the and to or. Then any of the statement is true, the answer will be true. Here one statement is true, therefore I will get true. Here one of the statement is true, the first one, therefore our answer will be true. Here also both of the statements are true, therefore answer will be true. Here both of the statements are false, therefore answer will be false. Let us run the code. You will get true, true, true for the first three and false. Not is used to reverse the result. Like if I have some variable and it is true, and I want to like print not of where and run the code, I will get the result as false. As the true becomes false, therefore it reverses the result. So this is the main use case of not for reversing some conditions. We will see what are the conditional statements in the Python and how to use if else and elif. So let us move to our Pycharm window, create a new file with the name conditional statements. Now in conditional statement we have if else. Now let us see how to use if else. So in Python we have to use if, then we have to write a condition over here. Condition should be in such a way that the result of condition should be either true or false. Condition should be either true or it should be either false. So when we have provided the condition, then we will write a statement in here. The statements are the things which we want to execute if the condition is true. For example, if the condition is true, I want to print something in here like the condition is true. Here we have to use colon to in order to know Python that the condition will be starting from next line, and the indentation is given over here, which by which Python will understand this block of code will be belongs to this if condition. That is, whatever I write in this indentation will be executed if this condition is true. Then what will happen if the condition is false? Then we have else statement for that, else, and we have to use colon again, and after that we will write the statement which we want to execute if the condition is false. For example, I will print a simple statement in here that the condition is false. Now if I run the code, let's see what is the output. The condition is true because I have given the condition is true. This condition can be directly true or false, or I can use some conditional statement in here, like 1 is greater than 2. This condition is false, therefore when I run the code, I will get the else part. The else will run if the condition is false, then else part will run. If the condition is true, then if part will run. True. So this is how we have to remember the things. If the condition is true, if will run, and the condition is false, else part will run. And the indentation will tell the Python that this part belongs to the if condition, and this indentation will tell the Python that this part will run when else condition is, or the if condition is false, then else part will run, and indentation will tell that this part belongs to the else condition. Then if I make this condition again true, then we will see that true condition is running. Now there is another statement which is elif. If we have multiple conditions to check, then we can use elif over there. For example, if condition, then I will print this is if part, then I will check some another condition using elif and give condition 2 and print this is elif part. As we haven't defined the condition yet, therefore it is giving us wrong. So then I can print I can use any number of elif condition in here. There is no such limits, so I can give condition 3 in here and print this is second elif, and at the end I can use else, and if I don't want to use else, I can skip that part. This is totally optional and depend on the condition or the program what we want to do. Then we will print this is the else part. So let us define the condition 2 and 3. Let's say condition 2 is false and condition 3 is true. Then all the errors are gone. Let us comment out this initial code and get this condition here. So I will make it false. So the third condition is true. Then when the third condition is true, this is second elif should print on the console. Let us run the code and see what is the output. Then yeah, we have got this output desired, which is desired. So let us change this things, like make it false. Then what should be the output? The else part should run and run the code. So else part have run. So let make the first statement true and run the code again. See, the if statement is run. So this is how we can play with if else. Now there is a catch. Let's say I make the second statement also true, then what should happen? You might think that these two statements should print, because the first two of the condition is true. But when we run the code, we get only if statement, because when Python find that this condition is true, the Python will stop executing another code remaining, and it will give the output and stop here, and will not check other another conditions. uh, it doesn't matter whether they are true or false, Python will stop over here. So this is how it works, and if I make it false, it doesn't matter, and if I make it true and make this false and run the code, then it goes to second condition and run it. And if I make this as true and run the code, then also this condition will run, and Python will not move to this condition, because it will see the only the condition before, only the first condition which is true. I will write it here. Let's write it here. If else will check only the first condition which is true and execute the statements belonging to that condition. Okay, and if he does not find any statement true, then else part will run. If all the statements are false, then else is run. Let's see that again. I have make all the statement as false, then see the else part have run. So this is it about the if else conditions in Python. So Python provides us two types of loop, for loop and while loops. Let us see them in detail. So let us go to our Pycharm window, create a new file, name it loops. Let us see what is a while loop. Now initially let us see what are loops. Loops helps us to execute same task again and again. So loops are used to repeat same task again and again. So let us see while loop. So while using while loop, we have to use while statement over here. Then we have to write condition. Let's say our condition is, let's say the condition is the condition, and let's define what is the condition. Condition is true, and we have to use colon as similar to if else statement, and we have to use the indent. This indent tells that this statement below while loop are belonging to the while loop. So I'm printing this is inside while loop, and when we want to exit the condition, this statement should be false. Then now we are inside the while loop, so let's make the condition as false. When while says this condition has become false, it will stop executing. Let's run the code. So we have printed this once because the condition was true. Therefore, while loop has printed this condition, and this condition was false. And when while loop again check this condition was false because we have made it, and then this statement was not printed because the condition was false. Let us see it in a easy way. Let us define a condition like while some number is less than 10 and define that number as 0. So this is the number 0, and while the number is less than 10 we have to print this condition. So we have to print this statement. So what we have to do, uh, when we print this condition we will get infinite amount of inside the while loop statements. We can stop the program, and these are infinite amount. So there, because the num is not increasing and num will always will be less than 10 to so what we can do to increase the value of num, we can add 1 to it. We can add num equals to num plus 1. So while during each of the loop the num value will be incremented by 1. So there will be once a condition false, and then this loop will break. So when we run this condition again we will get limited amount of inside the while loop. Let's print what is num. We can also print that and run the code. We will get them as it started from 0 and ends to 9. So we get 10 times this 10 a statement repeated because the count is starting from 0. So this is how we can use the while loop. So let us see the for loop. So to define for loop we have to use the statement for and I in range, and the range will be the thing on which we want to enumerate the I. So I is the enumerator and range is the range on which we want to enumerate the I. So I will use 0 to 10 and this condition. So I will explain everything in detail. So let us see what each of this means. So this for is the name of loop. So this is name, and then what is this I? I is the iterator. I is iterator. And what is this range? Range is we have to specify it start from where and it ends to which location, and this is the value by which we want to increase the I. When we compare it with the while loop, here the num is 0 and this is similar to the range starts from 0, and while num is less than 10 this is similar to this value, that is we are comparing it with less than, it should be less than 10. So and we are increasing num on each iteration. So this is that one, that is we increasing num by each iteration. So when we want to print something like this is inside for loop, and when we comment the initial loop out and run the code we can see 10 times this is inside the for loop has printed. When I print I with the statement and run the code, I can see we get the similar output as we have got with the while loop. For loop helps us to reduce the initial definition of defining the num and increasing it with each iteration. For loop handles everything with its range. So this is how we can use for loop. Where we have seen while and for loop. Now we will see how to use continue and break statement with these loops. We will start with the example. Let's go to our Pycharm window. I have written a question over here, which is find all the even numbers from 0 to 10. So we will use for loop in here. So for I in range, we will start from 0 and end with 10, and we will increase the value by 1, and we will check if statement. If I is divisible by 2, if I is divisible by 2, then the number is even. So if I is divisible by 2, remember mod returns us remainder, so the remainder is 0, then the number is completely divisible. Then we will check if the remainder is 0. We have to use equality. So to check equality, we have to use double equals to over here, and when we enter if statement, we can print I, it is even number. If this condition is not true, then we can go to else statement and print I, comma, it is odd number. Let us run this code and see what is the output. 0 is an even number, and 2 is also even, 1 is odd, 3 is odd, 4 is odd, and so on. So in this way we got even and odd numbers. Now if we want to store them in a list, we can define even list, and we can initialize with 0 numbers. Then let's initialize odd list. Then if I want to add some elements to the list, we have seen append method. So I will remove this print statement and use append method. Even as we are getting even number in a if statement, therefore we are adding this number to the even list, append and I. And similarly for the odd also, odd list dot append and I. Lastly, print this list, even list, and print odd list, and run the code. We can see all the even number are printed in the first list and all the odd number are printed in the second list. So let us see what are continue and break statements. Continue statement is used to skip the loop once. So and break statement will stop the loop. So when I use break statement here, so it will stop the loop when it encounters the first odd number. Stop. Let us run the code. See, when I was 0, we got even list dot append I. So 0 was appended to the first list, and on the second condition, when I was odd, that is when reaching to the 1, it encounters the break statement and the loop get stopped. So we haven't added anything to the list, and the statement were printed after that. So hope you have got the break statement. So then let us look at continue. Continue will skip the loop. So let us run the code, and we can see whenever we reach to the else part, that is when we want to open something to the odd list, the continue statement kicks in and skip that loop. That is on uh, every iteration of odd statement, that is 1, 3, then 5, then 7, and then 9. This continue statement was used to skip that part of loop, and so nothing was added to this list. And when even list was and everything was added to the event list, so we got everything in the event list, all the even numbers, but the odd list consists of nothing. So this is the difference between break and continue. I will also write that here. Continue skips the loop, and break stops the loop. We will see some of the most used built-in functions of Python. So let us go to our Pycharm window, create a new file, name it built-in functions. Let us declare a sample of numbers in a list. Now, minimum function is used to find the minimum value in an iterable object. Suppose if I want to find what is the minimum number in our list of nums, min will return me the minimum value from the list. Let us declare a variable, let's say min number, and I will use min function and pass it our iterable, which is nums. And when I print min n and run the code, I will get the minimum value as 2. If I add 0 to our list and again run the code, I will get 0 as the minimum value. Similarly, max function is there, which will be used to find maximum from our list of numbers. Let us declare a variable max n and use the function max and print max n and run the code. Suppose you don't have an iterable such as list or tuple available and you want to find minimum of two numbers, you can directly use min function, pass those two numbers to the min function. For example, I will pass 1 and 2, then this will print minimum of those two, which is 1. Similarly, I can use max and run the code. I will get 2 over here. In this way, we can also use min or max. Now sum is there to find sum of the numbers from an iterable. For example, if I want to find the sum of the nums, then I will declare variable sum of numbers and use sum and pass our iterable to this function, print sum of n numbers and run the code. I will get the value. In this way, we can use sum of n numbers. We can directly pass the iterable like 1, 2 and 3 and run the code. I will get 6. So in this way we can use sum function. Now we have round function to round decimal number. For example, we have a decimal number which is 1.5553, and if I want to round it to two decimal places, I can use round function. Let us print round of our number, and I want to round it to the two decimal places, so I will pass 2 over here and run the code. I will get it is rounded as 1.56. Similarly, if I want to convert it into an integer from decimal, I will not pass anything over here and run the code. I will get which is 2. In this way we can use round function. Then we have absolute function, which will return me an absolute value of the variable. Let us suppose I have a variable which has value negative triple one and another value which is triple one. Then absolute will return me the value without any sign. If I print absolute of a, then it will return me the value without any sign. And also when I pass the value does not have any sign or which is positive, it will not change it and return me the same value. So in this way we can use absolute to return the value without any sign. Then we have function named ASCII. ASCII function will return the readable value of the object we have passed into the function. For example, if I print ASCII of certain value, so it is a simple string, so it will return me the same string as it is a readable value. But if I pass some character which is unreadable and run the code, it will give me a readable format of it. So this is how we can use ASCII to get readable format. So this is all about ASCII function. Now if I want to find binary representation of any numerical object, then we have bin function. Let us set in action. If I want to see binary representation of, let's say, 1, then I will write bin and pass 1 to it and run the code. I will get as 1. If I want to say of some value such as 8 and run the code, we get the binary representation of 8, which is 1 followed by 3 zeros. Now you have also seen some object is also attached to our return value. So to avoid this, we can also use slicing over here. So I will print from the value 2 onward and run the code. I will get the binary representation of the number. So in slicing, I am just skipping the first two characters and returning all others. Let's say some other number such as, let's say, 4 and run the code. I will get 100. So this is how bin is used. Now we have character method to convert any Unicode value to its corresponding character. For example, if I want to print character of, let's say, 97, we all know 97 represent small a in Unicode. When we run the code, we will get a over here. So character is used to convert any Unicode value to its corresponding character. If I write 97 minus 32, I will get capital A. So this is how we can use character. Now we have ORD method, which is just opposite of character, which convert any alphabetic object into corresponding Unicode. For example, if I want to print Unicode of, let's say, A, I will write ORD and pass it A and run the code. I will get 97. Similarly, if I want to find for capital A and run the code, I will get 65. So in this way we can use ORD. Now we have two methods, is alpha and is digit, which is used to check whether the variable is an alphabet or it is a digit. Let us define an example and I will assign an alphabet to it. And when I want to check whether the variable is alpha or digit, then I will use print then name of variable and I will write is alpha and run the code. So it will return me true because it is an alphabet. Similarly, if I use is digit and run the code, it will return me false because it is an alphabet. So this is how we can use is digit or is alpha. Now let us move towards map and filter function. Filter will return only the values we satisfy some condition which we have written in some function. Let us copy our list here. Now if I want to find only odd numbers from this function, we have to define an function. We will see function in the next videos. Now let us just understand we have function which take a value and return true if the number is odd, else return false. Now let us use filter to filter this list and find odd numbers. I will use the function to convert the return value of filter into list. Then I will use filter function. Then I will pass isodd method, and then I will pass our iterable to it. And when I print odd list and run the code, I will get all the odd numbers from the list. So this is how we can use filter function. Now map function is used to apply certain condition over all the element of the iterable such as list. For example, if I want to add 3 to each element in a list, I will use map function over here. First of all, I have to define add 3 method. It will take the value and return value plus 3. We will convert our return value to the list, therefore we are using list function. Then we will use map, and we will pass the name of our function, which is add3, and then we will pass our iterable, which is nums. And when I print our list, I will get all the values incremented by 3. If you didn't understand the function yet, don't worry. We will be seeing what are the math functions available in Python which are provided by maths module. So let us go to our Pycharm window, create a new file, name it maths module. Now to use these functions provided by maths module, we have to import the maths module first. For this we have to use import statement, which is import math, and that's it. We have imported the module successfully. Now let us see what floor function does. Floor function works similar to the round function, but it will round the value to its lowest possible number. For example, I have a number which is, like, let's say 1.67, and when I use floor function to it, math dot floor, and when I pass num to it, it will convert this number to its lowest possible integer, which is 1, and when I run the code, I will get 1. Similarly, ceil is there, which will round the number to its largest possible integer. For example, I have a number which value is 1.23, and when I print math.ceil, and when I pass num to it and run the code, I will get 2. So it will convert it to the nearest largest possible integer. Similarly, if I write here 3.1 and run the code, it will convert it to 4. So similarly, we have square root function. Let's say we have a number 4, and if I want to find square root of that number, we have sqrt function. Let's see it in action. If I want to print math dot square root of number and run the code, I will get it as 2.0, because square root of 4 is 2. Similarly, if I want to find factorial of certain number, I will use factorial function. Print math.factorial of, let's say, 5. We know factorial of 5 is 120, so we will get 120 over here. Similarly, power function will find the nth power. So we will write math.pow to find power of certain number and pass the value at first position and the power at second position. So here we will pass 5 separated by 2 to find the square of 5. When I run the code, I will get 25, because 5 square is 25. And I can also find some fractional powers, such as, let's say, 0.5, which is square root of 5. It is 2.23. If I write here 25 and run the code, I will get 5. Similarly, there is a log function. So if I want to find the log of, let's say, 10 and base 2 and run the code, I will get log of 10 base 2. And if I didn't pass any value to it, it will find log base to the e. We also have some other function like print mat.log10, which will find log of the value of base 10 and run the code. It is 1. Similarly, we have log2, so it will find the log of value with base 2 and run the code. I will get the value as 3.32. If I pass here 2, it will return me the same value of base 2 log 10. So we have radians function. So radians will convert the unit from degrees to radians. For example, if I want to find radians of, let's say, 30 degree and run the code, I will get 0.52. Radians is used to convert degree to radians. Similarly, we have sine, cos, tan function. So we have to pass value in radians over here. So if I want to print sine of 30 degree, so I cannot pass 30 degree to this, so I have to pass the radians value. So I will declare some variable and assign radians value to it and pass this radians value to our sine function and run the code. I will get 0.499. Similarly, we have cos and tan. So this is how we can use sine, cos and tan function from the math module. So there are many more functions, but these are the function we will use continuously. See random module. So let us go to our Pycharm window and create a new file. Let's call it rand. And to use random, we have to import it. So import random. So the module has been imported. I will paste these things over here, comment them out. So let us see what random function do. So random function will return any random value which is less than 1. So let us see it in action. When I call random function from random module, it will return me the random value which is less than 1. When I call it again, I will get another value, but it will always be less than 1. So what if I want to find the random value less than, let's say, 100, then I will multiply this with 100 and run the code. I will get the random value which is less than 100. If I want to convert it into integer, then we have int function and run the code. You can get the integer. So this is how we can take advantage of random function. Choice, let us see what choice function does. Choice function will return me a value from certain sequence. For example, random.choice, and I have certain numbers in a list. Let's say these are the numbers and I want to choose any one of them, then I will use choice function from random module, and when I run the code, I will get any random choice from the sequence. When I run the code again, you can see always I am getting any random value from this list. Then we have randint function. So randint will return me any integer value which is specified within the range here. Let's say I want any random integer between 1 and 5, and when I run the code, I will get them. Let us run it again. So this is how we can use randint. So uniform is very much similar to random, but it will also return me the floating point or decimal values. Let's say it in action. If I want to find any random value between 1 and 6 and run the code, I will get any value including decimal values. So uniform is used to get uh, any decimal value within the specified range. We will learn list comprehension. So list comprehension is better than a for loop because we require less number of code to write a list comprehension, and generally list comprehension is faster than a for loop. And list comprehension can be used over any tribal object such as tuples, strings, array list, etc. So let us see an example to store 0 to 99 element in a list of nums. So by using normal for loop, initialize nums with an empty square bracket, and by using for loop, by using normal for loop, we have to append these elements, and at the last we have to print nums. So by using normal method, we have to use all these steps. Now let's see how to do it using list comprehension. Let us declare a same variable nums, and I want to achieve the same result by using list comprehension. I want to iterate from, let's say, 0 to 100 by using for loop. So I will write for val in range 0 to 100, and I want to store this value into our list of nums. So I will write the value at initial position, and when I print nums and run the code, I will get the same result. But this will be more faster than our normal for loop because we are making an append call which will take a more time, and because of that the list comprehension is a better way to do such things. Now let us see some more examples. Suppose we have the list of nums. I will add some random numbers to our list. Now I have initialized our nums with some random elements. Now I want to sort all the even numbers from these nums. So how to do it using list comprehension? I will initialize another list with the name even, and I want to store the value. So I will write value at initial position, and for value in range. So we have to iterate on nums. So I will write value in nums, and to see if the number is even or not, I have to use if condition. If value mod 2 is 0, then the number is even, then we will store that number into our list. So when I print even and run the code, I will get all the even numbers from this list. Now let us solve this question where we have to find all the numbers from 1 to 1000 which are divisible by 6. So let us declare our list L1, initialize it with square brackets. I want to store value, and I want to iterate for value in range from 1 to 1001. So in order to include 1000, we have to iterate till 1001, and I have to use if condition value mod 6 is 0, then this value is divisible by 6. then we will store that value into our list. So let us print L1 and run the code. You can see all the values are printed into our console till 1000. So now we want a list which has a length of word stored in it. So let us consider this list as our example. So I have a string. So to store each word into a list, we have a split method. So string dot split, and I want to split on every space. So let us print our words, and when I run the code, I will get all the words into our list. Now I want to store the length of each word. So length words. So I want to store the length of words. So I will write length of word, and for I have to write for loop for word in words. So we will iterate through this words list, and for each word we will store the length of word into our list. So when I print length of words and run the code, I will get length of all words. And if I want to store the tuple which contain the word with length of word, how I will do that? I will just write word comma and length of word, and I will complete the bracket. And when I run this, I can say store whose length is 5, len whose length is 3, op whose length is 2, and words whose length is 5. So this is how we can solve this question. Now we have this question in which we have to remove all the vowels from the string. So I have initialized a string and stored the string, and by using list method I have converted this string into its characters. Let us print list word and run the code. You can see all the words are converted into its characters and stored into the list. So now we have to remove all the vowels. So I will create a list of vowels first. Now let us store our answer in answer list, and I want to store the character. For this I have to iterate on list word. As we want to remove all the vowels, we have to use if statement. So what I'm doing here is I'm using for loop to iterate over the list of words, and for each character I'm checking if it is a vowel or not. If it is not a vowel, then I'm storing that character into our answer list. So in this way we can filter out all the vowels, and when I print answer, we can see all the vowels has been removed. E has been removed from the list, similarly O and E, A, and all the other words. So this is how we can use list comprehension. What is dictionary comprehension? All the benefits of list comprehension also applies to dictionary comprehension. So let us start with our first example. Now let us see how to initialize a dictionary and store the number and its square using a dictionary using normal for loop, and then we will see it how to do it using the list comprehension. Now let us start. So to store the square of a number and a number into a dictionary, we have to initialize the dictionary first. Now we have to use for loop. Now we want to store the number and its square, so I will write square dict and the key, and I want the square of key, so key star key. So it will give me the square and I will be storing that into our dictionary. So let us print square dictionary and run the code. You can see we have got all the squares from uh, 0 to 100. Now let us see how to do it using list comprehension. I have to store key and the square of key using for loop up to 100, and when I print square dict and run the code, I will get the same dictionary, but this will be more faster and more efficient than using a normal for loop. Now let's see some other examples. Now let us try this example using a list comprehension. So I will copy this code and print it over here. So I got a list of words, but I want to store the length as a key and value as the word. So I want length as key and value as word. So let us do it. So length words dictionary, and I want to store length of word and value is the word. I want to iterate over the words, and when I print length of words and run the code, I will get the length of word and the word. Now we have another question. Let's say I want to reverse key and value in previous solution. So how will we do that? So rev. So let us say name of our dictionary is rev. Then I want value and key. So I want to reverse key as value and value as key. I have to use for loop for key comma value in our length of dictionary items. So item returns the tuple of key and value. So we are just reversing and storing them into rev. And when I print rev and run the code, I will get the reverse of that. Here key was 5 and the value was words. So here key is words and the value is 5. So this is how we can reverse it. Now let us consider another example. Here we have a list of numbers and we have to store the key as number and value as whether it is even or odd. So let us do this. How will we do this question? So we have to use for loop to iterate over nums for value in nums. So value will give me each value. So we have to store the value as key and whether it is even or odd as a uh, as the value of that key. So we have to store the even if the number is even. So if val is divisible by 2, then we will store even, else we will store the odd. So print even odd and then the code, you will get 1 as odd, 2 even, 4 even, 6 even, 23 as odd, and so on. So this is how we will solve this question. Now let us see a last question about dictionary comprehension. We want to store the repetition of character in a string. So let us declare a string. Let us take the same string as our example. So, and I want to store how many time the let's say r has been repeated, then e has been repeated throughout the string, and so on. So how will we do that? So let us declare an answer dictionary. So we want to store the character and the repetition of character, that is count of character, and I want to iterate or iterate over ex, and when I print answer and run the code, you can see the r has been repeated 3 times, e has been repeated 2 times, p has been 1 times, and so on. So this is how we can solve this question. Generators. So generators are used to hold the state of any function. So in any program where there are a long running for loops or while loops, then we can use generators to hold the state of a function. Now let us define a long running for loop to find even numbers. Let us define a function, let's say even number, and it runs a for loop which iterates over 2000 numbers, and if I is divisible by 2, print statement, and let us see if this code works or not. Even number and run the code. So it gives me even numbers up to 2000, but let's say we have certain condition. uh, I want first 3 even numbers now, and after that another even numbers. So we have to use generators. In order to use generator, we have to use yield statement. Now I want to print the first even number. So let us say even number. Let us start this loop from 1, so it will not give me 0 as an even number. So when I print g and run the code, so it will give me a generator object, but we want the number, so we will use next method and pass g to it, and when I run the code, I will get the first even number, which is 2, and when I run the code again, when I copy and run the code again, I will get 4. So you must have seen that the state of our code is stored, and when I run the code again, it started from 4. So it remembers the last stage it have worked up till, and then after that it will start. In this stage, it worked up to the first iteration. Then in this stage, it worked on a second iteration. And if I want first 10 numbers, then I will use a for loop. Let's say for I in range, and I will run it up to 10. And when I print next stop g and run the code, I will get another 10 numbers, 10 even numbers from our generator. So this is how we can use generator to hold the state of the for loop, and we can get the even numbers whenever required. Now let us see an example. We have a list of nums with elements such as 1, 2, 3, 4, 5, 6, 7, 8, and 9, and I want to find square of each number. To create a generator over this, we will use a similar syntax of a list comprehension, but instead of square bracket we will use round brackets, and as I want the square, so I will use value to the power of 2, and using for loop for value in nums, I will iterate over the list. So when I print L2 and run the code, you can see a generator has been generated, and when I print next of L2 and run the code, I will get the first number, and similarly if I run the code again, I will get the square of 2, and when I print it again, so I will get square of every number from the list. So this is another way to generate a generator using a list. Let us create a new file. Now iterators are used to iterate over objects such as list. So let us declare a list of numbers. Now to generate a iterator for this list, I have to use iter keyword. So let's say an iterator, and to generate the iterator, I have to use iter keyword, and I have passed list to it. So our iterator has been generated, and when I print iterator and run the code, you can see we got the object of iterator. Now iterators are more efficient than iterating over a list directly. So to print a number, we can use a next method like a generator, and when I run the code, I will get the first value. Similarly, if I run the code multiple times and run the code, I can get another values from the list. So this is how we can use iterators. Now if I want to print first two numbers using next function, remaining numbers using a for loop. So for I in range, and I will get a length of list, and I will subtract 2 from it because we have already printed first two numbers, and when I print next of iterator and run the code, I will get all the values from our list. So this is how we can use iterator. In another way, we can also directly iterate for the iterator, and when I print value and run the code, I will get the same result. So this is also a way to iterate over iterator. Now we have a complete dedicated library of Python over Itertools. So let us import that library. Import Itertools. Take our example. So if you want to iterate over this list infinitely, we have cycle method. So how to use that? So we can use for loop, and by using itertool.cycle, I have to pass the list name, which is L, and now I am able to iterate over this list infinitely. And when I print I and run the code, you can see it is a never ending cycle. So let us break this code. So in this case, we have to use some statement to break this loop. For example, if I want to say if the value of k reaches to 100, then I want to break this loop. So every time I enter into the loop, I have to increment the k value by 1, and if k reaches to 100, then I want to break this loop. So I will use break keyword, and I will make this equals to, and if I run this code, I will get it running only up to 100 times. So this is how we can use Itertool.cycle. Now we have chain method to combine multiple lists. So let's say we have uh, three lists with name L1, L2 and L3. Let us change this value a bit. So I have a first list with 1, 2, 3, 4, then second list with 11 to 11, 22, 33, 44, and a third list with 10, 20, 30 and 40. Now I want to iterate over all these lists by using a single for loop. Then how can I do that? So I can use for I in Itertools dot chain, and I will pass our name of list, which is L, then L2, then L3, and when I print I in a single line, so I will use end statement, and when I run the code, I will get all the values of all the list using the Iteratools in a single line. So this is the first list, then 11, 22, 33, 44. This is a second, and this is the third. So this is how chain method can be used from Itertools. Now, if I want L3 to be printed again and again, so we have repeat method in Itertools. So let us see it in action. Itertools dot repeat, and I want to repeat, let's say L3, store the count somewhere. So I will initialize a count variable, and when count reaches to 100, I have to break the loop, and when I print I and increment c with 1, so here I am just keeping the count, so we will not run into an infinite loop. When the count reaches 200, I am just breaking this loop, and by using a repeat function from Itertools, I am repeating L3 again and again. So when I print this code, I will get 100 times uh, the list L3 is printed over here. So you can see we have got L3 100 times. Now let us see how to use iSlice from Itertools. Let us copy our code. Now we have to chain this list using chain method. So let us store the chain method in a variable, it's ch, and itertool dot chain, and I will chain L, then L2, then L3. Now I want to iterate only up till 10 elements. Then how will we do that? So I have slice method. So for value in itertool, itertools dot islice method, and I want to iterate over ch, and I want to start from, let's say, 0, and I want to print somewhere in the mid of L2. So let us take an example of 12, and when I print the val, let us print the answer on the same line, and when I run the code, you can see I have started from L, I have printed the whole L, then I have reached up to 22 and stop there. So this is how we can use iSlice to slice through an iterator created by itertool.chain. Now if I want to count certain elements, then we have count method in Itertools. So let us see it in action. So for value in Itertools dot count, let's say I want to count up to from 10. So let's say I want to count from 10. So I will pass the starting value as 10 and I cannot pass the ending value. So I have to keep the count somewhere in the external variable. So let's say our count is 0 and after each iteration I will increment our count by 1, and if count reaches to let's say 100, then I break the for loop and I will print our value. If I want to skip certain number, let's say I want only even number starting from 10, I will pass 2 over here and run the code. So I will get only even numbers starting from 10. So this is how we can use count method to count, and we can pass the starting position which is 10. So you can see here the iterator has started from 10 and it will skip every second element. I can also pass 5 to skip every 5 elements and run the code. I will get every fifth element starting from 10. This is how we can use count method. Now we have permutations method. So let us have a list. Let us copy L3. Now if I want to find all the two permutations from L3, I will use Itertools.permutations method. So I will print Itertools.permutations and I will pass L3. I want to see two permutations, and when I run the code we will get Itertool object. So in order to get all the permutation, we have to convert this Itertool object into a list by using list method. After using list method and printing it, we will get all the permutations from L3. Now let us see a two dice problem. I will convert a list into dice which have 6 faces 1 to 6, and when I print the permutations of L3 and 2, I will get all the permutations when the two dices are rolled simultaneously. So this is how we can use Itertool.permutations. Let us learn what is lambda functions in Python. So lambda function is also called an anonymous function. So lambda function is basically a function written in one line, and whenever we have an use case where the function has to be declared and used only once, we can use lambda function over there. Let us see an example. First we will write a normal function and then we try to write a lambda function for the same thing. Now here we are asked to write a function to double a certain number. So we have to define a function and let us name it double. It will take a value and then we will print value multiplied by 2. So let us see how this function works. So I will call double and pass the value 5 to it. When I run the code, I will get 10. So how will we do this using lambda function? So I have to use lambda keyword, and what I want to do is I want to take the value and I want to multiply this value with 2, and that is how we write the lambda function. Now we want to store this function, so I will use a variable name, let's say double. After storing this variable, I will print double and I will pass the value of 5 and run the code. I will get as answer 10. So this is how we can write a lambda function and pass value to it. Now let us write a lambda function to find the power of particular number. So let us give it a name, power, and use the keyword lambda. And I have to take two values, first value and the power value, and I want to find the power of x, so I will write x to the power of p. So when I want to print power of, let's say, 5 square, so when I run the code I will get 25. Let us check what is 10 to the power of 5 and run the code. I will get it as 1 lakh. So this is how we can write lambda function. Now we know how to write the filter and map functions as we have seen in previous videos. Now how to use that with the lambda function? Let us see that. Let us start with filter. Let us define a list of nums. I have added some random numbers to our list. Now I want to find all the even numbers from this list by using a filter function. So how I will do that? So I will store the answer in L2. Then I will convert the return of filter into a list by using list method. Then I will use filter function. First I have to pass the name of function, and then I have to pass the list, which is nums. So instead of passing the name of function, I will directly write the lambda function over here, which will be lambda. I will take x as an input, and I will check if x is completely divisible by 2. Then I will store that into our list, else we will skip that number. And when I print the L2 and run the code, I will get all the even number from our list. Similarly, to get all the odd numbers from our nums, so I will declare another L3 and I will use filter. I will pass lambda function as x, and when x is not divisible by 2, I will store that number and I will pass our list. And when I print L3 and run the code, I will get filter object because I haven't converted it into our list. So let us convert that into our list and run the code. I will get all the odd number from nums. So this is how we can use this with filter. Now let us find all the numbers which are divisible by 5 by using lambda function. So let us declare another list which will be L4. I will convert the result into list and use filter function. So to write lambda function, I will use keyword lambda. So I will pass a variable and see if it is divisible by 5, and I will pass our nums. And when I print L4 and run the code, I will get all the number which are divisible by 5. So I hope you have understood the filter function, how to use it with lambda functions. Now let us see how to use map function with lambda. Now we know the map function is used to make certain changes to our list. So let us do some changes. For example, I want to increment all the number from this list by 2. Then how will we do that? Let us declare a list m1 and I will convert the result into list. Use map function. I will pass here a lambda function which will be taking a number and adding 2 to that number. After this I will pass the list to this function, and when I print m1 and run the code, I will get all the numbers which are incremented by 2. So 1 has become 3. Similarly, 2 has become 4 and 4 into 6 and so on. If I want to find square of each number from our nums, so how will we do that? Let us write a lambda function. I will square the input and pass nums to the map, and when I print m2 and run the code, I will get square of every number in our list. Now if I want to store even and odd instead of the numbers into the list at that place, so let us do that. List, then use map function and write a lambda function x, and we will write even if x is divisible by 2, and else we will write odd, and I will pass the nums, and when I print m3 and let us print nums also, so we will be able to compare both of those. So 1 is odd, 2 is even, 4 is even, 223 is odd, similarly 5 is odd, 32 is even, 65 is odd, and 23 is odd. So this is how we will do that. Back to the lambda function. So how this function will work, I am taking x as an input and I will be passing even if this condition is true, and if this condition is false, I will be passing odd to the function. So this is how this function will work. Let us learn file operations in Python. So I have created file operations file and an input file where all the input has been stored. So we will be using this file to perform file operations. So let us go to our Python file. So let us learn open operation. So to open a file, we have to use open operation. So let us say open. I have to give the path of a file which we have to open. So the name of file is input file and it is located in the same directory as our Python file. So my file path will be only this much. By writing this operation, we have opened a file in a reading mode. So I have to store this object into a variable, let's say input file, and now we have opened this file. If I want to close it, we have close operation. So if I write input.close, so our file is now closed. But before that, let us perform some reading operations. So if I want to store all the content of the file into some variable, let's say data, and I want to store all the data, so I have to use read operation. So data has all the content of this input file as a string. So when I print data and run the code, you can see all the data has been printed of the input file. So if I close this file and now I try to read the data and run the code, I will get an file operation error. So after closing the file, I cannot read any data or write any data of the file. Now let us suppose I only want first 25 characters from the data file, then I have to pass the length here. So I want 25 characters, so I have passed 25 here, and when I print data and run the code, I will comment this code out first and run the code. I will get first 25 characters from the file. If I only write 5 and run the code, so first 5 character has been printed. So this is how I can pass number of characters into a read function. So that will return me that many characters into our variable. Now let us see a readline function. So readline function will return me each line. So let us store that in a line variable, and I want first line. So I will use a readline function. We have to print the line first and run the code. I will get the second line. But you might have seen the lorem has been skipped and the file has been directly started with ipsum. So it has read all this character. So how file operation works is, when we open the file, the cursor is on the 0th position, and when we have read something from a file, then the cursor has been moved over here, and when I call a readline function, the function will read the data from this onward. So this is how file operation works in Python. So it remembers the cursor position and will start after that. For example, if I run the read line again and print the line again and run the code, you can see uh, first we have got lorem because of this, then the cursor is reached at this position, then after a read line is called, this line was printed, and we are now on this line. Now our cursor has reached to this line, and when I print this line by calling readline function, this line has been called, and now our cursor has been reached to line number 3 in this input file. So let us try and print this again, and now our third line was CRAS. When I run the code, you can see the third line has been printed as CARS, and this is how we have to use a readline function. Then there is another method of readlines. Now readlines will return me a dictionary of all the lines from the input file. So let us try that. So I will initialize a variable lines and use input dot read line, input dot read lines, and when I print lines, let us comment out our old code. Let us see what is the result. So we have got the list with all the data, and each element of the list contains a line. So when I try to print lines of 0, then it will give me the first line, and 1, it will give me the second line. And when I want to print first 5 lines, so I will use slicing as :5 and run the code. It will return me first 5 lines in the form of list. So this is how we can use readlines function. To open each file, we have to use open keyword, and to close it, we have to use close. Sometimes we may forget to close the file, but if the file is very big, then it may cause certain problems like your code may get slow. So in order to avoid that, we have a with method. So by with method, the file will be closed automatically after the work has been done. So how to use with method? So I have to write a with keyword. Then after that, I have to use open statement. Then I have to specify the name of file, open, then input file, and I have to use as and the name of object, which is input. So this is how we can use with a statement. So let us try to print some lines. So I will print input dot read, and let us pass some 100 characters and run the code. So you can see first 100 characters has been printed. Let us give it as inp2 and inp2 and run the code. So first 100 line has been printed, but if I try to access inp2 outside with a statement and run the code, I will get an error. So file has been automatically closed when you exit the with indent. So when you exit this indent, the file has been automatically closed. So this is very efficient way to use file operations. So your file will be automatically closed after the use. So now we have read, write, and append methods, and also read plus, write plus, and append plus methods. Some more functions about file operations. Now let us start with write operation. Initialize an object of, let's say, write, and I want to open the file, let's say input file 2, and I want to open it using a write operation. Now you can keep your eye in our directory. Here we don't have input file 2, but the write operation, when I run this code, will create a new file. Before that, I will just comment out our old code. Let us run the code, and you can see the new file has been created, but there is no content yet. If we have to add any content to this file, we have write method similar to read into a read operation. So write, and I have to pass a string what I have to write. Let's say I have to write some sample string, and when I run the code, and when we go to the input file 2, you can see the sample string has been written here. By using only write method, we cannot read the content of file. If we try to read and run the code, so this will give me an error. But to tackle that, we have write plus method. So if we open the file in write plus mode, so we can also read the content of file. So let us try to read. I will store it into content, and when I print content and run the code, so it will give me nothing over here, because as we have seen in previous example also, the cursor will reach to the end. It will start reading the file from the start. Then we have written the string and the cursor has reached to the end. So it will give me nothing, but it will also will not throw any error. So to reset the cursor, we can either close the file. Let us close it first, and let us open this file again into a read mode and run the code. You can see a sample string has been printed. So there is another method to reset the cursor. We can use a seek method, which is wr.seek, and I have to pass 0, 0 to seek the cursor at 0th position. And when I run the code, I will get a same string. But uh, when I don't seek the cursor and run the code, the cursor is already reached at the end and will not return me anything. So we have to seek the cursor at the start. So this is how we can use write plus mode. Write plus will provide me an additional functionality of read plus write. This is helpful when we want to read and write the file. Let us see what is append and append plus method. Now append plus method will also create a new file if I don't give it an existing file. But for this example, let us give it an existing file, which is input file 2, and I will open this file into append mode. And when I try to append something, let us close this file. Closing the file is always good for performance improvement of our code. So let us close this file, and now I have opened this file. So let us write something. For example, if I want to write sample text 2 and run the code, and when I see here, so sample text 2 has been added to our previous file. As we haven't added space over here, so it appended without giving me a space. So let us try to add a space here and run the code. Then we can see here we got a space. This is about append, and in append method also we cannot read anything. If I try to read and run the code, I will get an error. But for this we have append plus method. Append plus method will provide me a reading functionality. Let us store this file into a content variable, and when I print content, now when we read the file from this position, it will only provide me the previous content. But we can use seek 0, 0 and then run the code. You will get whole string as an output. So this is how we can use append and append plus method. Now let us see read and read plus. Now when we open the file without specifying any mode, it opens in a read mode. So this is equivalent to this. So if we don't specify anything over here, it will always open in a read mode. So let us remove the first line, and if I write re.read, and when I print this and run the code, I will get the content of input file 2. But what is the use of r plus method? The r plus method will provide me a write functionality. So if I try to write anything without using r plus method, array.write, let's say I want to write sample content, let's say 3, and when I run the code, it will not give me any error. It is also not appended in this file. So if I use r plus method and run this code again, you can see the sample content 3 has been appended. So r plus method also provide write functionality. So let us revise what we have learned so far. So we have seen read, then read plus, then append plus, then write, and write plus. So all these things we have seen in this video, and let us discuss. Read provide me only reading functionality, then read plus provide me read plus write functionality. Now append provide me append append functionality, uh, plus if the file is not present, it will create it. So this functionality is provided by append. Now append plus, it provides append plus read plus if the file is not present, it will also create a new file at that location. Now write provides a write functionality, then it also creates a new file if it is not present at that location. Then write plus, it will write the file, then read the content from file, and also it will create a new file if it is not present at that location. So this is all about file operations in Python. We will be looking functions in Python. So what are the use of function? So function makes our code more readable. It helps to make the code modular. We can reuse the code once it is defined in a function. And what is the function? It is just a block of code. So let us go to a Pycharm window. I have created a file of functions. Now to define a function, we have def keyword, and by using def, we are telling Python that we are defining a function. Then we have to give the name of function. Let's say I'm defining a function to add 10 and 20. So the appropriate name for the function will be sum 10 20, and uh, we are using colon to indicate that we are defining the function in following lines. So let us create a variable to store the sum. Let's say it as a, and I will store 10 plus 20 into it, and then we will return this a. So this means when I call the function sum 10 20, it will return me the value of 10 plus 20. So how to use this function? I have to make a function call. So how to do that? I just have to write the name of function and use empty parenthesis because we are not passing some anything here. So we are writing empty parenthesis over here. So by this the function call is done, and when I run the code, it will print nothing to the console because we haven't printed it yet. So if I write print statement and run the code, it will return me 30 because sum of 10 and 20 is 30, and I am returning that sum, and here I am printing it. Similarly, if I did not make a call, it will do nothing. It is not always important for a function to return something. If I print the value of a here itself, then there is no need to return anything. And when I call the function, then I don't have to use the print statement over here because I have used that over here. and when I run the code, I will get 30. Now you might have seen this function is not doing much important thing because it is just finding sum of only two element, which is 10 and 20. Let's say I want to find a sum of 40 and 50. This function will not able to do this. But what if I modify this function in, let's say, sum of two numbers, and I pass the two numbers here, let's say num1 and num2. So here we are passing some external variables to this function, and this is also called as parameters. And I will what I will do is add these two variables, which is num1 and num2 over here. So whatever I will pass here will be added and printed to the console. If I call this function now, which is sum of two numbers, and I pass it 40 and 50 and run the code, I will get the sum as 90. Similarly, I can do 10 and 20 and run the code, which is 30. So we have seen on the slide that it makes the code more reusable, so we can reuse this code as many times. Let's say I want to print sum of 10 and 30, and I call this function again, and here I want to print sum of, let's say, 100 and 200 and run the code. It can be printed as many times, so it makes our code reusable. So here we can see that there is a function and it adds the two numbers. By this we can see that this makes our code more readable. Just by seeing this function we can say what this code does, which is adding the two numbers. So this makes our code more readable. We will see how to pass parameters to the functions. So let us see how to pass parameters with respect to the position. Let us suppose I want to define a function which says hello to the user. So I will name the function as hello user. I will take the first name and last name of the user, and in the return I will say hello first name lname. So this is the function which take first name and last name and joins hello to the first name and last name of person. Here we are taking the first name at first position and then we are taking the last name. So while calling this function, we have to pass the first name at the first position itself and then last name. For example, we have a person whose name is Dev Patel. Then I will call this function hello user, and at the first name I will pass Dev, and at the second place I will pass Patel because this is his surname and this is the first name of the person. Now this function is returning me some value, so I have to store that value at some place. So I will store this value in the variable h, and when I print the variable h and run the code, I will get the result saying hello Dev Patel. But if I pass something like a numerical value here, but here we are taking a string, the numerical value will throw error, and when I run the code, so we will get error because the numerical value cannot be added to the string. So we always have to pass the arguments with respect to the positions. So here we have to pass the last name, whatever it is, so it will be printed in the console. Now we have a person who is not interested on giving his last name here, so we will set this last name to some default value, which is an empty string, so the user need not to add the last name to this function. So when calling the function hello user, I just have to pass dev. When I print the variable and run the code, I will get hello dev. But there is another user, let's say it a D1. He want to show his last name. So what he will do is, let's suppose the name of the person is dev2 and the surname is, and when I run the code, I will get dev2 Patel. So by using default parameters, you can choose either to pass that value or you can skip that value. When you skip the value, the default value will be assigned, and when you pass the value, the default value will be overridden and the new value will be added to the string. If I want to set a first name to a blank statement, so it will not work because in this case order matters. Whatever the value you want to keep default, you have to place them at the last in the sequence of parameters. Now suppose we have a function which take first name and last name and also two values, and add those two values, say hello to the person. So let us define that function. So this is our function. It takes first name, then last name, then two values. It add those two values. Then this function calls hello to the user and return the sum of the two values. As we cannot add a number to string, so we are typecasting our number to string first and then we are adding that string to our answer. So let us call this function, store the answer in variable, let's say d. Then I will pass as first name and last name as Dev Patel, and I will add two numbers, which let's suppose 21 and 31. And when I print, I will get a result as hello Dev Patel and your sum is 52. But let's suppose you have defined this function and now your friend want to use it, but he don't know at which position he have to enter the first name and which position he have to enter second name, and similarly where to insert the values for the same. So for this we can use keywords. Let's suppose we have a person D2 and he want to call the function. Then by using keywords I can say it like I want to enter the first name, so I will uh, write here f name equals to, and I will write first name, let's say dev2, then last name. Similarly for while 1 is equals to, let's say 20, and while 2 equals to, let's say 30. And when I print t2 and run the code, I will get hello dev2 patel2 and your sum is 50. So here it is not necessary to write everything in a position. So I can write a first name over here and last name over here and run the code. I will get the same result. This is how we can use keywords and pass the value to the function. Let's suppose we have to develop a function. We have to develop a function which takes any number of parameters and returns me the sum of it. So how will we do that? So let us define a function, add numbers, and to in order to accept multiple values as an input in Python, we can use star and accept those values in any variable. Let's suppose we have a val over here. When I print val, let us see how the output looks. First let us call the function and pass values. I will pass any random values to it. Similarly, call this function multiple times. As this function is directly printing and not returning any value, so I'm not using any variable to store anything or print. So I will run the code, and as you can see, all the values we have passed to the function stored in a tuple, and it is being printing with the val. Now we know that we can use for loop over a tuple, so let's use that for, let's say, element in val, and let us declare a variable of addition. Let's set it as 0. So I will add each element to the add. Now at last I will print the add because it is holding all the addition of our elements. So when I run this code, I will get the addition. So we have declared a function which takes any number of values and return sum of it. So this is how we can accept any number of elements in Python. Now there is another method to accept multiple elements in Python. Let us suppose we have a form which take name, date, age and mobile number of a person. But in web form you might have seen we have given a choice to enter, let's say, date, and if you want to skip the age, I can do that and submit the form successfully. So how can we implement that in Python? Let us see this in action. Let us define a function, name it a form function. Now we do not know how much of the information the person is submitting. So what will we do here is we will use two stars and to the variable name as info, and for now we will just print the variable. Now let's suppose there is a person 1 and he want to add his name, then today's date, then his age and mobile number. So person 1 wants to add all the values, so he is adding his name as, let's say, XYZ, then today's date, let's say date and month, age as, let's say, 21, and mobile number 999999. And there is another person 2, let's say, he want to share his name and he forgot to add the date and he had his mobile number. Then there is another person, let's say person 3, he added the date but he don't want to give his personal info such as age and mobile number, so he submitted the form with this element. Now when we run this code, you can see the info has been printed and the info is in the form of dictionary. So everything the person has passed into the function is stored in a form of dictionary. If you want to print it using a for loop, how will we do that? So we know we can use for loop on dictionary. So I will give me the keys of the dictionary. So how will we write that? I will use a print statement, then I, and separated by the value, which will be info of I. So it will return me key and value pair on a separate line. When I run the code, I will get the name of first person as XYZ, then date, age and mobile number, then this person 2, name, age and mobile number, and person 3 with only name and date. So this is how we can take any number of arguments using the two star followed by the variable name. If the values are of same kind, we can use a single star and pass those values of same type to the function. So this is it about parameter passing in Python. Hello and welcome to this video. In this video, we will see what is recursion. In simple terms, when function calls to itself, it is called recursion. Now let us start with a simple example which is non-recursive. Let us say I want to find factorial. So for a non-recursive function, I have to iterate by using a for loop. Let us define that function factorial. I will take a value and use for loop. To store our answer, we have to initialize a variable. Let's say our answer variable, which will store our factorial, will be initialized to 1. Then for every loop, we will multiply our element with the answer, and at the end we will print our answer. So this is the simple example to find the factorial of a number. So let us see if it works or not. Let's say factorial of 5 and run the code. So here we have to start with 1, because when it is multiplied with 0, we will get our answer 0. So we will start with 1, and when we run the code, we will get 120 over here. So let us see how to do it using recursion. So I will define another factorial function. So you can figure out the difference between the normal function and recursive function. Now let us define our factorial recursive. I will take a value. Now I will return our value multiplied by our function, and I will pass it the value -1. But every recursive function should have a stopping condition. So here our stopping condition will be when our value becomes 1. For example, our value becomes 1, then we will stop. This is because if our value becomes 0 and we have multiplied 0 with our answer, we will get it as 0. So in order to avoid that, we have to stop when at the condition when our value becomes 1. So let us run this code. I will print factorial recursive of 5 and run the code. I will get as 120. Now let us see how this code will work in the background. We will call factorial recursive function by passing the value 5. So I will write that here and I will pass 5 to it. Then we will check if the value is 1. It is not, so we will return value into factorial of value -1. So here value, that is 5, multiplied by factorial of value -1, that is 4. So after this, what will happen? Again value will be checked. If it is 1, it is not. Then what will happen? 5 into 4 into the factorial recursive of value -1, which will be 3. Then again it will be 3 into and factorial of value -1, which will be 2, and again 2 multiplied by factorial of value -1. So factorial, when it will be reached to 1, we will check if the value is 1, and when the value is 1, we will return 1 to it. So when 1 is returned over here, what will happen? So when this condition returns 1, we will get this multiplication, and when it is evaluated, we will get 120 as our output. So this is how recursive function works in the background. Now I hope you have got the idea about recursion. We will learn object-oriented programming in Python. Object-oriented programming help us to imitate a real-life entities. For example, if I want to create an object of animals, we can do that using classes. We can build a class of animals, then we can have a name for it, then the name of its species, then we can allocate ID to it, and we can also add a description of that animal and so on. Similarly, if I want to develop a employee management system, we can add a name of employee, gender, then we can also add department, many other things related to the employee. This is the advantage of using object-oriented programming in Python. So how would we achieve object-oriented programming? Python provides us classes and objects. Class is a factory or a blueprint where the objects are created. For example, if I have a class of, let's say, employee management system, then this employee management system will provide me the name of employee and name of employee, ID, age, gender, salary, department of employee, etc. Then the object will be the real life thing which will be employee. That is, if class is employee management system, then the object of this class will be employees. Now I hope you have got the basic understanding of these things. You will learn more while coding. So let us create a new file in Python. Now to define a class in Python, we have to write a class. Then the name of class. For our example, it was employee management system. So I will write EMS. Then we can write a function. For example, if I want to set the ID of employee, so I will write a function define set ID. Then object of this EMS will be employees as we have discussed. So let's say employee one. So how to initialize this object? We have to write equals to sign and we have to write the name of class which is EMS and the closing bracket. So the employee one has been initialized. If I want to pass the ID of this employee, let's say 101, then name of this employee, let's say Rajesh, and his age, let's say 45, and his salary, let's say the company has base salary of 50 lakhs. So then we write that over here. So the employee one has been created. Now we have to accept these values. So we have to accept these values in our EMS. So to accept these values, we have init method. Uh, so init method will be automatically called when the object has been created every time. So Python automatically passes this employee object. So whenever the object is created, Python automatically passes the name of object to all the methods written in the class. So we have to write self. Self is just a keyword. We can write anything instead in place of a self, but it is the standard convention used by many of the developers. So we have to write a keyword to accept this object. Now after that, I want to accept the ID. So I will write ID, then name, then age, then salary. And let us initialize one other variable of number of days and let us initialize it to 0. So whenever the new person had joined to the company, a number of days will be automatically initialized with 0. We are using a default parameter to initialize this. Now we have passed these things to init method. Now we have to create variables to store that. So in order to store the variables, so we have to write self dot id is id, which means this self.id will store the id that I have passed through this variable. I can also use variable names different than the names we have used here. For example, if I want to write emp name instead of name, so I can do that, and this will be assigned to name that we have passed here. So h. So we have created all our variables. Now, if I want to get the person's ID, employee one's ID, so I will write a get method. So get ID, and I will return the ID for which the object has been called. For example, now I have initialized emp1 object. So if I want to access emp1's ID, then I have to write get ID method, and when I run the code, I will get 101 in the console. So this is how we can get the ID. I can also write emp1.id directly and run the code. I will get the same result. Similarly, emp1.name, if I want to access and run the code, I will get Rajesh, age 45. So in this way, we can access all the data we have passed to that object while initializing. So one of the benefit of using class is once we have declared the class, we can initialize as many object as needed. For example, now new employee has joined, then I don't have to create a new class. I just have to define M2 and initialize our EMS and pass uh, then the new ID, then name, let's say Sham, age is let's say 23, and his salary is 50 lakh 1. And when I try to get the ID, I will write get ID method, and when I run the code, I will get it as 102. Now let's say that employee 2 is doing a good work in company, and his salary is to be increased by let's say 2000. Now what we have to do is we can directly write dot salary, and we can assign a new value to it. Let's say I want to increase it by 2000, then it will be like this. And when I now try to print m2.salary and run the code, I will get a new salary over here. And if I try to print the old salary, I can do this and run the code. I will get the old salary and the new salary. I can also define a function, let's say salary hike. So whenever a person gets salary hike, we will take percent, by how much percent the salary has been increased. So after getting the percent, we have to add to it our salary. So self dot salary equals to self dot salary plus percent multiplied by self dot salary. So we are incrementing the salary by that much of percent. So let's say, so instead of using this method, let us try to use our salary hike method. If I want to uh, use salary hike, then I have to pass the percentage. Let's say increase it by 20%. So I will pass it 0.2. Let us try to print it before and after. So m2 dot salary. This is before the hike. Let us copy and paste the same. And this is after the hike. And when I run the code, I will get the before the hike the salary was this much, and after the 20% hike I will get it is at 60 lakhs. So this is how we can define a functions inside a class. Now if I want to define a function which will give me the employee info, what I will do is define a function. So get employee info, it will take a self, and I will print id employee id is self dot id, print his name, self dot name, age, self dot age, and lastly the salary. So we have defined a function to print all the info. Now let us try to print all the info of our employee one. So emp1 dot get emp info, and when I run the code, let us comment our employee to out and run the code. I will get all the info of our employee one. Similarly, if I comment this out and try to print the info of, let's say, employee 2, then m2 dot get info, and when I run the code I will get the info of employee 2. So this is how we can do that. Now as we have seen, we can access and modify any variable inside the EMS. For example, if I am an employee and I will change my salary to, let's say, my salary becomes then uh, 3 crores or something like that, and uh, then each time I will get the salary as 3 crores. So this should not happen. So we can declare such sensitive information variable as a private. So to make variables private in Python, we have to use double underscore before that. So this variable has become now private. So I cannot access that directly. So I will get an error. So here also we have to change our salary name. Here also I have to change it. And when I run the code, so we cannot access salary now. So when I comment this out and run the code will run perfectly fine. We have declared our salary as private by using double underscore, and if I try to access our salary, I will get an error that salary does not present. If I use double underscore over here and run the code again, I will get the same error. So now we cannot modify our salary, or we cannot view either. So every time I have to modify any thing in salary, I have to use salary hike method. If I want to see the salary, then what I have to do is I have to declare another function, let's say get salary, and it will return salary. And as I cannot access using this, so I will use get salary and run the code. I will get the salary, and if I want to hike the employee to salary, so I will use salary hike function and pass it the percentage, which is, let's say, 30%, and when I run the code I will get incremented salary. So this is how we can make variable shape by using uh, the private variable, and it will make the variable private, and we cannot modify that variable after that. For modifying that variable, we have to define a function inside the class. So this will be more secure than doing it directly. Now, if I want to check all the variables from, let's say, employee one, then we have dict method. So if I want to print, let's say print emp1 dot underscore underscore dict, then this will return me all the variables that we have initialized in employee one. So let us run the code, and we will see all the things about employee one has been printed to the console. I hope you have got an understanding about classes and how to use them. Learn and explore some more things about object-oriented programming. So let us create a new file first. So we have created a new file and let us define a class of animals here. So to initialize animal, let us define init method. So we will initialize animal with its, let's say, species, then color, then let's say max age. So let us create a variables. So we have created all the variables. So let us define some methods to access these variables. So I will define get species and I will return species here. Then let us define get color, return self dot color, define max age, get max age, and let us return self dot max age. So we have written some methods to get these things. So let us see the concept of inheritance. Now, now in biology, you must have heard we inherit many of the common things from the parents. So if I want to, let's say, define another class of, let's say, reptiles. So after defining reptiles, I have to write all the things of animals into reptiles also because reptiles also has species, the color and also max age. So instead of rewriting whole things, we have the concept called inheritance. So we can inherit everything that of the parent class. So the as animal class contains the name of species, color, and max age, I want to inherit all those things into reptiles. So I will write a rounded bracket over here, and I will specify the name of the class which I want to inherit. So it is animals. Let us make this R capital. So now we have inherited animals into reptiles. Now we don't have to write all these things again. Now to init reptiles. Now we know reptiles. Most of the reptiles have tails. So I can directly write the tail size. Then they have claws. Let say it as number of claws. How many claws they have. Uh, then their average weight. So let us initialize variables also. I will do that quickly. I will also create a get method for all the three variables. So I have initialized all the get methods here. Now let us uh, initialize a reptile. So let us say we have find a new species of crocodile. So let us name it as crocs. Initialize it with reptiles. Pass the tail size as, let's say, 300 centimeters. Then it has a 5 claws on each legs, so I will write 5, and the average weight is, let's say, 100 kgs. So we have initialized a reptile. So we have successfully initialized our new reptile species with these properties. Let us try to print some of the properties. Let's say I want to print the tail size, then weight, then let's say what we have now, clothes. and when I run the code I will get all the things. Now as we have inherited animals into reptiles, I can use all these things that belongs to all the animals, that is species, colors and maxage. So let us set all those up. So our new reptile species belong to crocodiles, so I will write croco, and it belongs to the species of croco. So I will write dot species over here, then dot, let's say color of our species is, let's say it is light brown. Then what we have, max age. So this crocodile lives up to, let's say, 50 years. And when I try to print dot get color and run the code, I will get it as light brown. Similarly, I will write get max age and species and run the code. I will get all the things about our new crocodile species. So this is how we can do this, but if we try to remove animals from our inheritance, I will get error to all these properties because we cannot use these properties now. So inheritance is used to avoid repetition. So if I want to declare another group, uh, another class with let's say vertebrates, or another new class of, let's say, of birds, then all these things will be common. So I can inherit animal class to all of those. So this is how we can use inheritance to avoid repetition of code. We also can define a setter method. So let's say set animals, and we can take all these things here and initialize these variables. So whenever we found any new reptile species, I can do just like dot set animals, and I can write here it is a new species, then the color is, let's say, brown, and the max age is, let's say, 40. And let's comment out this code, and when I run the code I will get this all the things, but I don't have to write these things again and again. So this will be the time saver in this case. So I hope you have understood the inheritance. Now let us see what is function overriding. Function overriding. So in function overriding, the function in a child class. So as we know that this is our parent class because it is providing us properties, and this is a child class because it is inherited and getting the properties from parent. So it is child class. So any properties that is written in a child class with the same name will be overridden in the parent class. For example, if I write a same property, that of animal, let's say get color. So as we know that animal also has a get color property. So when I write this get color property over here, then the property written uh, in animal get overridden by the property written in the child. So let's say I want to return the color, but uh, after a research, it is known that every color in reptile is of a light shade. Then I will just write light and I will add it to our color. So now every color we have added to the animal, which it will turn into a light shade of that. Now if I try to print the color, so we have a get color method we have called. So let us initially comment this code out and run the code. So we have got the brown color. Now if we override this method from parent and run the code, I will get the light brown, because this method has overridden the method in parent class. So also the Pycharm shows that this method is been overridden. So if we hover over this, we can see this is overwritten. So this is how we can override a methods. Now I hope you have understood what is inheritance and also what is function overriding and also called as method overriding. Let us learn some more concept about those. So let us start with class variable. So we will use the previous example of employee management system. So I have created an object and used our class to instantiate the object, and here I have accepted the variables and initialized them. Then we have one method of getID and I am returning the self.id. So to initialize a class variable, we just have to write the name of variable. Let us say the name of variable is employee count, and to initialize it, I will assign it to 0, and thus we have created our class variable. Now to access this variable, we have to use the name of class. For example, if I want to print the value of our emp count variable, so let us print the employee count. So I have to use the name of class ems and dot and employee count, and when I run the code, I will get the answer as 0. So this is how I can access the count. Now I can also modify the count just by writing the name of the variable and assigning it to value. Let us print the value again and run the code. So value was 0 before, and after modifying the value we got 12 over here. So if I want to increment the count whenever new employee is added to our system, so how can I do that? So as we have seen, we have to use the name of class to access the class variable. So let us write ems dot emp count, and I will write plus equals to 1. So every time the new object is created, we know that init method is called. Then every time init method will be called, then we are incrementing the variable by 1. So let us erase this code. Now we know that we have one employee. Let us try to run the code, and when I run the code I will get 1. Let us try and create more employees. Let us name them employee 2 and employee 3. So we have created 3 employees. Now let us see our count has been changed or not. So our count has become 3. So this is how we can access the employee count and also increment it. Now to work with the class variable, the Python provides us class methods. So to use class method, we have to use decorators. So decorators start with @sign, and the name of the decorator is class method. So I have to write class method. After the class method decorator is declared, below that line, I have to write the class method. So def, and the name of class method is increment employee. So in class method, we are passing CLS keyword. It is very similar to the self keyword, but in self keyword we were passing the name of object while initializing the object. In the class method, we are passing the name of class, which is EMS. As we have passed EMS in this CLS, so I can write CLS dot mcount plus equals to 1, and every time the init method is called, I have to increment the employee count. So EMS dot, so I have to remove this over here and I have to write EMS dot increment employee. So whenever init method is called, I am incrementing one employee and I have used class method. In the class method, I have declared the method to increment employee and I am passing the class and I am incrementing the count by 1 every time a new employee has been created. So let us try and print the employee count. I will get the same thing. Let us try and comment one employee out and run the code. So still there are two employees. So this is how I can use class variables and class method. Now we also know that how to make these variables private. So we just have to write double underscore before that. So after writing double underscore, so no one will be able to modify it from outside the class. So in order to access this, I have to write another class method. So class method get count. I have to pass CLS and CLS dot mcount. I will return this and let us print the count of employee. EMS dot get count and run the code. I will get the count of number of employees. Now beside this we have a static method. So static method does not take any keyword. So if I want to define the static method to add some numbers, let's say add numbers, and it takes three arguments and it returns the sum of it, a plus s plus d. So let us try and use that. So to access the static method inside a class, we have to use the name of class ems dot add numbers and I have to pass the numbers and run the code. I will get the sum. So this is how we can use static method. So in class method takes the first argument as the name of class, and in static method it does not take anything. And for other methods inside a class, it takes the name of object as the first argument. And if I want to change the keyword, a name of keyword, I can do that. Let's say I want to change the name of keyword as, let's say, EMP. So it will also work, and we also have to change it over here, EMP, and run the code. So it will not produce any errors because we can give any name to the keyword, and self is just a standard notation used by many developers around the world. So it is better to use self. So it is always better to use the standard practices, but it will also work if you do not. So I hope you have understood how to declare the class variable, class method, and static methods. We will be looking at data structures and algorithm. Now let us start with the data structures. Data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. Now algorithm is a collection of steps to solve the problem. Now coming back to data structure, depending upon your requirement and project, it is important to choose a right data structure for the project. For example, if you require to store the data linearly, you can go with list data structure in Python. Then there are mainly two types of data structure. The first one is linear data structure and the second one is non-linear data structure. In a linear data structure, elements are arranged in a sequence one after another and the memory is allocated at once, and Then the elements are added to the memory one after another. But after passing a certain amount of element, the linear data structure may get hard to access and consume more memory. The example of linear data structure are array data structure, stack, and queue. In array data structure, the element in a memory is arranged in a continuous memory. All the elements of array are of the same type, and the type of element can be stored in the form of array is determined by the programming language. Stack data structure. In a stack data structure, elements are stored in last in first out approach. That is, the element which is stored at a last will be removed first. You can imagine the pile of book which is kept on a table where you can access the book at the top, and if you want to add the book you can only add that book at the top. So in this way you can imagine the stack data structure. Then we have queue. In a queue, the data is added in the first and removed from the last, which means the data stored in a queue at the last will be removed first. Now we also have a linked list. In a linked list data structure, the data elements are connected through a series of nodes, and each node stores the data and address of a next element. Now let us go toward the nonlinear data structure. Unlike linear data structure, the elements in nonlinear data structure are not arranged in any particular sequence. Instead, they are arranged in a hierarchical manner where the element will be connected to one or more element in a series. Nonlinear data structure are further divided into graphs and trees. So graph in a graph data structure, each node is called as vertex, and the vertex is connected to another vertices through edges. In a tree, as similar to graph, the tree also have a vertices and edges, but in a tree data structure, there can only be one edge between the two vertices. The most common tree which is used is binary search tree, where each node has two childs attached to it. Now let us see some differences between linear data structure and nonlinear data structure. The data items arranged in a sequential order in linear data structure, and in nonlinear data structure, the element does not have any specific order. In linear data structure, all the items are present in a single layer. In nonlinear data structure, they might be present in different layers. In linear data structure, memory utilization is not that efficient. In nonlinear data structure, memory utilization is efficient as compared to linear data structures. Now let us move toward algorithms. Algorithms are nothing but a steps to solve a problem. Now the algorithm to be good, it should have input and output which is clearly defined. Each step in an algorithm should be clear and unambiguous. Algorithm should be most effective among many different ways to solve the problem. An algorithm should not include computer code. Instead, it should be written in any language and can be implemented and should be written in any other computer language. Now, why should we learn data structures and algorithm? Every big company like Google, Facebook, Amazon, or Netflix, they ask programmers about data structures and algorithm questions in their respective interviews. So if you want to clear these interviews, you must know data structure well. So if you know the data structures and algorithm precisely, you can clear every interview of any big company. So it is always important to learn data structures as a programmer because it helps us to improve our thinking and the logic to solve any problem. So data structures are very important and every programmer must learn it. I hope you have got an idea about data structures and algorithms. Cover stack and queues. So let us start with the stack. So stack follows LIFO approach, which means last in and first out approach, and the insertion and deletion in the stack happens at the same end. For example, we can represent a stack using a bunch of books kept on each other. We can access only the topmost book, and we can keep the book on the very top, which means insertion is happening at the very top and deletion is also happening at the very top. So this is how we can understand the stack. Now we have two operations for the stack. The one operation is to add an element into the stack, which is the push operation. So I will write that over here. So push. So in the push operation, we will pass an element which we want to add into the stack. So this element can be anything depending upon the problem. It can be either an integer, string or list or anything else. Then to remove an element from the stack, we have pop operation. When we call the pop, it will pop the topmost element from the stack. For example, if I delete this element, for example, if I call the push operation, and if I want to add, let's say 100 to the stack, so I will call push 100, and this 100, so this 100 element will be added to the stack at the top. When we call pop on the stack, the topmost element, whatever it is, will be removed. So 100 will be removed. If I again call the pop method, again the element which is on the top will be removed, and this will follow until the stack is empty. If the stack is empty and we call the pop method, we will get an error. Let us suppose if I push 101 and this is my element 101, and if I call push method on the stack, then this will add 101 to the stack. Then if I call push 100, then this element will be again added to our stack. So this is how push and pop operation on a stack works. Now let us move toward the queue. Now queue follows first in first out approach, which means insertion and deletion happens at the opposite end. Means whatever the element which we have entered at the first will be removed first. For example, if we imagine the people waiting for a movie ticket outside a movie hall, then the first person will take the ticket and move out of the queue, and then second person will go for the ticket on the ticket counter and get his ticket and move out of the queue. And similarly, if a new person come, he will be joining them at the last. So this is how queue works. Now we also have two operations for the queue. The first operation is called as enqueue. Now in enqueue operation, I can pass the element which I want to add. After calling an enqueue method, that element will be added at the last of the queue. And then we have a dequeue method. When dequeue method is called, whatever the element which is at the front of the queue, which will be removed from the front of the queue. For example, if I want to enqueue, let's say person 1 to our queue, then I will call the enqueue and I will pass the person 1. to our enqueue function, I will pass the person1 to our enqueue function. Then this enqueue function will add the person1 at the last of our queue. And if I call the dequeue function, the person whoever is on the front, let's say person 13, will be removed from the queue. Then these other persons will be adjusted, and if I again call the dequeue, then the person on the top will be removed. If I again call the enqueue function with passing person 13, then the person 13 will be added at the last of the queue. So this is how enqueue and dequeue operation on the queue works. So let us summarize this. So we have stack and queues. So stack follows last in first out approach, and we have queues which follows first in first out approach. Now insertion and deletion at the stack happens at the same end, and insertion and deletion in queue happens at the opposite end. At the stack we have push and pop operation. Push operation will push an element at the top of stack, and pop operation will remove the element from the top of the stack. Now enqueue function in queue will add the element at the last of queue, and dequeue function will remove an element from the front of the queue. From now on, we will start with data structures and algorithm. In short, it is also called as DSA. So we will start with linked list. So linked list is a linear data structure, and it stores the data as similar to array. So there are two types of linked list. The first one is singly linked list, and the second one is doubly linked list. So we have two types of linked list. The first one is singly linked list, and the second one is doubly linked list. So here is a representation of singly linked list. So the singly linked list will have a head, and the head pointer will point to the first element of the linked list, and this element combines together called as a node. So here is a representation of node. So the node will have a two blocks, and in the first block of node it will stores data. So here you can see it has store 5, and the next block will store the address of next node. So here you can see the head is pointing to the first node, and the first block is storing the data, which is 5, and the next block is storing the address of the next node, and it is represented by using an arrow. And also you can see then the next node is storing 3, and the block which is attached to the 3 is storing the pointer to its next node. Now the last node will store the null value. So if we have to attach any next node to this, for example, if I want to attach this, then I will remove this node. For example, I will remove null from this, and then I will point this arrow to this next node. That means now I have added a node successfully to it. Then what I have to do, I have to add some data here. Let's say I have added 44, and after that one more thing is remain. I have to add null value in the next. So this is how we can create a next node and add value to it. So this is singly linked list. So let us see doubly linked list. I will remove this first of all. Yeah. So in doubly linked list is very much similar to the singly linked list, but the only difference is as in singly linked list, the next pointer is pointing to the next node. In doubly linked list, the next node will be pointing to the previous node. So we will have a two pointer. For example, so we have head, then we have the next node, and the next node will point to the previous node, like this. Similarly, this node will also point to the previous node. So this is how we can represent a doubly linked list. And if I want to add this element to the last, then what I have to do? I have to first of all erase the null. I will erase the null, and then I will point this node to the next node, which is this, and also this node will be pointing to the previous node. So this is how we can add the next block. And also we have to write null over here, and also the data, let's say 88. I will move this over here. So this is how we can add data element at the last in a doubly linked list. So in a singly linked list, we have all the arrows pointing to the next element. So while traversing the singly linked list, I can only traverse through starting to the end. For example, if I start from the head, then I can go to 5, then I can go to 3, 8, and then 88. But I cannot reverse traverse this list. I cannot go to the previous element. But in a doubly linked list, as we are pointing to the previous element, I can traverse to the previous element, because we have the pointer which is pointing to the previous element. That is why we can traverse in a reverse manner also. This is the next arrow, and this is the previous. So by using next arrows, we can traverse in a forward direction, and by using the previous pointer, we can traverse in a reverse direction. So this is how doubly linked list can be used to traverse in both direction. For certain examples, it will save us more time because we have a way to go to the previous element. So let us go to a Pycharm window and let us try to create a singly linked list first. Let us close all the previous work. I will create a new directory for our TSA. Create a new Python file for singly linked list. So singly linked list has a node. I will write that down over here. It has a node. Then we have a head. So these are the two main elements of the linked list. So let us start and try building a node. So I will write a class for node, class node. Now I will initialize a node class. So dev underscore underscore init. I have to store the data. So I will write data. So in order to move to the next element, we have to write a pointer to next. So that is self dot next. So let us initialize it to none. Then we have to store data. So I will initialize data with the data we have passed while initializing the node. So as we have seen in the diagram, we have a node, and the first block has a data and the second block has the pointer to the next node. So here we have written, we have the next, and then we have a data. So data will store the data, and next will store the address of the next node. We can also exchange their position. So data is at the first position and the next will store the address to the next node. So let us create a single linked list. I will write a class for head. So I will name it as linked list or a single linked list, because we are creating single linked list right now. Single linked list, so it will be more easy to understand. Then I will initialize it, and single linked list will start with head. So I will write self dot head, and it is not pointing to anything, so I will write none over here. Now let us start building a single linked list. So I will initialize a node named A with values. I will take the values from our list, which is 5, 3, 8, and then 88. So I will initialize A with 5, then B node 5, 3, then C with 8, then D with node 88. So we have initialized all our nodes. Then we have to use single linked list to connect them all. So let us try that. Initialize a single linked list name SLL. So SLL equals to SLL. So I have initialized our single linked list. So we have initialized our single linked list. So I will make A as our head. So I will point our head to A. So how can I do that? So SLL dot head is A. So now our head pointer is pointing to A. That is our head pointer is pointing to 5. So this is how we can represent that. Now our A, that is 5, is pointing to 3. That is 5 is pointing to 3. So I will write A dot next equals to B, because the next is pointing to the 3. So here the 3 is represented by B. So A dot next is B. So similarly B dot next is C. Also C dot next is T. So we have written all the nodes, that is 5 is pointing to 3, 3 is pointing to 8, and 8 is pointing to 88. So A dot next is pointing to B, which is 3, then B dot next is pointing to C, which is 8, and C dot next is pointing to D, which is 88. Let's see how to traverse through the linked list. So we have head pointer. So we can point the temporary pointer to the head. So let us make that. I will use a text box. So I have created a temporary element which is temp, temporary pointer which is temp, and I will point to that head. Then after pointing to the head, I will use a while loop, and when the temporary pointer reaches to the null or none, so as in other languages like C, C++ or Java, it is called as null. So in Python, it is referenced as none. So when the temporary pointer reaches to none, I will stop our while loop. So when this reaches to none, I will break the while loop. But before that, I have to traverse through each element. So what I will do is I will use while loop. Then I can use the next property, as we know that next property will allow us to reach to the next element. So uh, I will use head dot next. Then after using that, I will reach to the first node. Then I can use I can use temp dot next, because we have temp element pointing to this element. So the temp dot next will allow me to go to the next element. Then we will go to the 8, and then we will go to the last element. And when we will find the none, that is when we will know we have reached to the last element, we will break our while loop. So this is how we will work. So let us go to our Pycharm window. Let us start building the while loop to traverse through our linked list. So we know that we have to point a temporary element to our head. So I will write temp equals to single linked list dot head. So our temp is pointing to the head element of our linked list. So I will write while loop while temp is not none. So until we don't find a none element, we will continue traversing to the linked list. That is, we will start from head, and until we are not finding the none element, we are not stopping the while loop. Now we have written the condition. That is, when we will not find any none element, we will continue traversing to the loop. So let us print the data temp dot data. So while traversing to the each element, we will print the data of that node. So to print data in a single place, I can use end, and I can use this sign. So it will represent a linked list. And to move temp to the next element, I can use temp equals to temp dot next. So after traversing through the node, I will point temp to the next element. And let us try and run this code. So we have started from 5, then 3, 8 and 88. So here also we have written the same thing. So if you are able to run this code without any error, so congratulations for building your first linked list. Let us see doubly linked list. So I will create a new file. Let us name it DLL. Let us modify our single linked list and make it a doubly linked list. I will copy our single linked list and paste it over here. So I will write here DLL, which represent a doubly linked list. So in doubly linked list, we have a node and we also have a head. But in a doubly linked list, we have two pointers. One pointer is pointing to the next element and another pointer is pointing to the previous element. So let us create the previous pointer. Let us name it prev and assign it to none. So we have created a two pointers. So the first pointer will pointing to the next element and the second pointer will pointing to the previous element. Now we have created a DLL class. So in DLL class we will have a head. So let us keep this node this way only, and instead of creating a single linked list we will create a doubly linked list. So we have initialized our doubly linked list. So DLL and also DLL. So head is pointing to A, then A is pointing to B, but B should be also pointing to A as we have seen in our diagram. 5 is pointing to 3, but 3 is also pointing to the 5. So let us perform that operation. So B dot previous is pointing to A. So A is pointing to B and B is pointing to A. So similarly B is pointing to C. So C will be pointing to B. So C dot previous is pointing to B and C is pointing to D. So D should be also pointing to C. So D dot previous it is pointing to C. So we have four nodes. So first node is A. So A is pointing to B and B is pointing to A. The second node is pointing to the third node and third node is pointing to the second node. And the third node is pointing to the fourth node and the fourth node is pointing to the third node. So this is how we can build a doubly linked list. So it is very simple if once you understand the single linked list. So our temporary element is pointing to the doubly linked list head. So this while loop will work the same. So as we are moving our temporary variable from head to the first node, then to the second node, then to the third node, and when we are finding that there is a none element, then we are stopping it. So let us run the code. So we will be getting the same output. Here I will make a small change. If temp.next is none, then I will print none is none and run the code. So you can see we have made the changes. So 88 will be pointing to the none as we have seen here 88 none. So as we have seen while discussing the doubly linked list, we can also traverse in a reverse manner. So we know that our last element is D. So I will initialize one another temporary pointer which will be temp last, and I will point this to our D. So we have the last element. Then I will write a while loop to traverse in a reverse manner. So while temp last is not none. So while it is not reaching to the head element, I will keep traversing. So I'm traversing until the temp last does not reaches to the head. So let us print the data of last element, which is temp last dot data. And let us traverse to the previous element, which is temp last equals to temp last dot previous. So we are traversing in a reverse manner. So let us print all the variables, all the data in single line. So I will use end equals to, and as we are traversing in a reverse order, I will use reverse arrow. I will copy the if statement from above code and let us paste this here. So we are traversing in the reverse order, so I will change it to previous, and we will reach head at the last, so I will change it to head. So let us try and run the code. So we got an error. Let us make it temp last and let us run the code. So I'm getting the list in a reverse manner. So this is how we can traverse doubly linked list in both the manners, that is from starting to end or from ending to the start. See how to add new element to our linked list. So let us see how to add the new element singly linked list first. Then we will see how to do it with a doubly linked list. So for a single linked list, we have to traverse from head to the last element. So here D is our last element currently, which is 88. So here, when our temporary element is reached, then we will remove the null or none from there, and we will create a new node and add new element, which is E, and then we will point D to E, and then E will point to the none. You might be little bit confused, so let us start coding this thing and you will understand. So let us do with single linked list. We will use the previous example itself. So let us create a function to add element to the linked list. So I will create a function, define add element. So I will take the head of the linked list for which I have to add the element, and I will take the new element which we have to add at the last. Let us name this as last. So add element at last. Now let's create a temporary variable which will point to the head. Now we will iterate over the time while we until we reach to the last element. So while temp dot next is not none, we will iterate it. Temp equals to temp dot next. Now by using the while loop, we have reached to the last element. So we have reached to the D. So now our temp is at D. So we have to link E to the temp. So let us do that. So temp dot next equals to the new element, but we cannot directly assign new element to temp dot next because we have to create a node first. So let us create a node of E equals to node of new element, and let us assign E to temp dot next. Now here we have created the function. So temp is passing to the head first, then we are iterating until we reach to the last element. Then the last element will be pointing to the new element. So the new element will be added at the last. So let us try and add the new element. So add element last. So I will pass the head, which is sll dot head, and I will pass new element as 99, and let us print the list again. So to print the list, I have to use the while loop, and when I run the code, everything is printed in the same line. So I will print an empty space over here and run the code. So you can see the 99 has been added at the last. What we can do is we can also create a function to print the list. So let us do that. I will create a new function, define print list. I will pass head to it. Then I will paste all the code, and this temp will pointing to the head, and then we will print all the data. Let us copy the if statement from the doubly linked list over here. Now instead of using the while loop, I can directly write the function print list, and I can pass sll.head. Let us run the code. So I'm getting the two linked list before adding the new element and after adding the new element. Now I hope you have understood how to add a new element to the single linked list at the last. Now let us see how to add new element to the doubly linked list. So it is very similar. Let us first create the print function first. I will just create it in a moment. I have created a function to print a doubly linked list. So let us create a function to add the element at the last. So let us copy our single linked list function and make the changes at that function. So you will be able to understand it better. What is the difference between single linked list and doubly linked list? So we are taking the head of a doubly linked list here and the new element. Now we are moving to the next, and after creating a new element node, then we are assigning last element to E. Then this E should also pointing to the previous element, which is temp. So let us do that. E dot previous equals to temp. Now we have successfully added an element to the doubly linked list. Now let us add the element. Let us pass the head dll dot head, and let us pass a new number which is 99. And when I print list and pass it the head, let us run the code. So you can see 99 has been added successfully. This is how we can write the function to add element at the last for doubly linked list and the single linked list. See how to add an element at the beginning of linked list. So let us consider that we have an empty node. So here we will add any data that we want. Let us say if I want to add 100 as a first node. Now I have successfully created a node. Now I have to join this element to the first node of our linked list. So let us do that. So I have joined our node to the first element. Now I want to point the head to our new node. So let us get an arrow and point our head. So now our head is pointing to a new node and our new node is pointing to the next element. So we have successfully added this element in between the head and the next node. So this is now considered as the new node at the beginning. So let us try and code this thing. So let us try and create a new function to add the element at the beginning of list. So I will write define. Let us copy it and paste and add element at beginning. So I will write peg. Let us take a single linked list as our first input and new element. So let us create a node first as we have discussed before. So n is our new node with the value of new element. Now we know that the node should be pointing to the next element of the head. So n dot next equals to head. We have passed single linked list over here. So I will write ssl dot head. Now our head should be pointing to our new element as we have seen in the figure. So head should be pointing to the new element. So I will write sll dot head equals to n. Now we have created a function to add the element at the beginning. So let us try and run this function. So I have written the name of function. I am passing the name of our linked list, which is SLL, and passing a new element. So let us try and run this code. So you can see we have successfully added 100 at the first of our element. So I'm passing here our list. I'm accepting it in our function and passing a new element. Then we are creating a new node. Then our new node is pointing to the head, and the head is pointing to the node. As we can see, our new node is passing to the new element, the next element, and head is passing to this node. So the same thing we have implemented here, and let us try and add another node at the beginning. Let's say 101, and let's run the code. So 101 is now added at the beginning before the 100. So this is how we can add new node. Now let us implement the same function in doubly linked list. So I will copy the same function. So let us paste that here. So I will accept here a doubly linked list. As we know that we also have a previous pointer. So the previous pointer should be pointing to the new element. So tll dot head dot previous should be pointing to the new. Then new should be pointing to the head, and similarly head should be pointing to the new element. Now let us try and add an element at the start, element at beginning. Let us pass our linked list and let us add 100 and print the linked list, and let us run the code. So we have added 100 to our doubly linked list. So this is how we can add an element at the beginning of doubly linked list and also in the singly linked list. Let us see how to add an element anywhere in between the linked list. So if I want to add this element, let's say at the second position, then what I have to do is I have to first traverse to this second last element. If I want to position this element at second place, then I have to traverse the list up to the first element. Then after reaching this first element, then I have to connect the first element to the new node, and then I have to connect the new node to the next element. This is how we can add a new element between the two elements. So let us try and implement that. So def add element at location. I will take the singly linked list, then new element, then the location at which I have to add the new element. Now I will use for loop to traverse the list. So for I in range location -1, because we have to traverse one element previous to the location. So now we have reached to that location. So if now create a temporary pointer to traverse. So ssl dot head. So it is pointing to the head. So if the temp is not none, that is we are traversing, and while traversing, if it does not reaches to the end, then we will traverse to the next step. Temp is temp dot next. Or in case if we have given the value which is greater than the size of our linked list. So if I say that I have to add at 100th position, but our linked list only has 4 elements, so I cannot do that. So I have to use else condition, and I will print location is out of bound. So I am telling user that our linked list is not that long, and I will break out of loop. We have reached to the specific location using temp equals to temp.next. Now let us add that element in between. Let us create a new node. So n equals to node of new element. Now we have to create a new pointer for next to point the next element, which is temp.next. That is, this next element will be pointing to this node. This will be pointing to this node. Now we have created the next pointer. So temp.next is will be pointing to n. So now this element is pointing to the new element. Now let us make the new element point to our next. So n.next is pointing to the next, and as we know, next is pointing to temp.next, which is this element. So this new element will be pointing to the next. So we have created a function to adding a new element at any location. So let us try and run that. So add element at location. So I will pass it a single linked list. The new element, let's say 1000, and I want to pass it at the second location. Let us print list, and I will pass our head to that list. Let us run the code. So you can see that at the second position we have passed 1000. So it will count from 0, so it will be 0 1 2. But if you want to pass at the second position itself, counting from 1, so we can write here -2, and let us run the code again. So 1 and 2 we have passed 1000 over here. Now let us implement the same function in doubly linked list. I will copy this function. Let us paste this into a doubly linked list. So I will take here doubly linked list. We are pointing our next to the temp.next. Now temp.next is pointing to n. So n.previous should be pointing to the temp.next. As this is pointing to n should be pointing to the temp.next. So n.next is pointing to next. So next.previous should be updated with n. So this is how we have modified this function to work with a doubly linked list. So let us try and add the element anywhere in the beginning. So add element at location. I will pass doubly linked list. Then let us add 1000 at, let us say, third location. Then print the doubly linked list and run the code. So I have added 1000 at the third location, 1 2 and 3. So this is how we can add an element at in the doubly linked list as well as in the single linked list. Let us see how to add an element anywhere in between the linked list. So if I want to add this element, let's say at the second position, then what I have to do is I have to first traverse to this second last element. If I want to position this element at second place, then I have to traverse the list up to the first element. Then after reaching this first element, then I have to connect the first element to the new node, and then I have to connect the new node to the next element. This is how we can add a new element between the two elements. So let us try and implement that. So def add element at location. I will take the single linked list, then new element, then the location at which I have to add the new element. Now I will use for loop to traverse the list. So for I in range location -1, because we have to traverse one element previous to the location. So now we have reached to that location. So if now create a temporary pointer to traverse. So ssl dot head. So it is pointing to the head. So if the temp is not none, that is we are traversing, and while traversing, if it does not reaches to the end, then we will traverse to the next step. Temp is temp dot next. Or in case if we have given the value which is greater than the size of our linked list. So if I say that I have to add at 100th position, but our linked list only has 4 elements, so I cannot do that. So I have to use else condition, and I will print location is out of bound. So I am telling user that our linked list is not that long, and I will break out of loop. We have reached to the specific location using temp equals to temp dot next. Now let us add that element in between. Let us create a new node. So n equals to node of new element. Now we have to create a new pointer for next to point the next element, which is temp.next. That is, this next element will be pointing to this node. This will be pointing to this node. Now we have created the next pointer. So temp.next is will be pointing to n. So now this element is pointing to the new element. Now let us make the new element point to our next. So n dot next is pointing to the next, and as we know, next is pointing to temp dot next, which is this element. So this new element will be pointing to the next. So we have created a function to adding a new element at any location. So let us try and run that. So add element at location. So I will pass it a single linked list. The new element, let's say 1000, and I want to pass it at the second location. Let us print list, and I will pass our head to that list. Let us run the code. So you can see that at the second position we have passed 1000. So it will count from 0. So it will be 0 1 2. But if you want to pass at the second position itself, counting from 1, so we can write here -2, and let us run the code again. So 1 and 2 we have passed 1000 over here. Now let us implement the same function in doubly linked list. I will copy this function. Let us paste this into a doubly linked list. So I will take here doubly linked list. We are pointing our next to the temp.next. Now temp.next is pointing to n. So n.previous should be pointing to the temp.next. as this is pointing to n should be pointing to the temp.next. So n.next is pointing to next. So next dot previous should be updated with n. So this is how we have modified this function to work with a doubly linked list. So let us try and add the element anywhere in the beginning. So add element at location. I will pass doubly linked list. Then let us add 1000 at, let us say, third location. Then print the doubly linked list and run the code. So I have added 1000 at the third location, 1, 2 and 3. So this is how we can add an element at in the doubly linked list as well as in the singly linked list. Let us implement stack in Python using a list. So I will initialize a list named stack. So list is initialized with a square brackets. So I have initialized a list. So stack follows last in first out approach, which means element in the stack are added and removed at the same end. Then we have push and pop method in the stack. So let us write push and pop method first. So I will start with writing a push method. So push stack. So push stack method will take an element and we have to add this element at the top of the stack. So I will write append method and pass an element. So append method will append this element at the last of the stack. Now let us write at the pop method, pop stack. So pop does not take anything and removes the element at the very end of the stack. So stack dot pop the element. So this is how we can write push and pop methods in a stack. So let us try and add some element into our stack. So I will write push stack and pass, let's say, 1000. Let us print the stack. So we have 1000 added in our stack. So let us try and add some more elements. So we have added 1000 to 1003 elements to our stack. So you can see each element is added on top of each other. So first 1000 was added, then on the top of that 1001 was added, and then 1002 and 1000 and 1003. So let us try and remove the element using a pop method. So pop stack. So pop method should remove the element on the very top. So 1003 should be removed first. So let us try and print the stack to validate it works or not. So print the stack and run the code. So you can see the element on the top, which is 1003, is removed from the stack. So this is how we can implement a stack using a list in Python. So let us remove some more element. So again 1002 has removed. So let us try and push, let's say, 999 and print the stack. So 999 has added on the top of the stack. Now I hope you have understood how to implement the stack, push and pop methods using Python list. Let us start and implement the queue using Python list. So I will initialize a list using with a name queue. So queue follows first in, first out approach, which means the very first element which we have entered will be removed first, and we have enqueue and dequeue methods to add and delete element respectively. So let us start with implementing enqueue method. So define enqueue method and it will take an element. So enqueue will add an element at the end of the queue. So I will again use append method. So enqueue, so queue dot append element. So this element is added at the last of queue. Now let us define the dequeue method. So define dequeue. So dequeue method will remove an element from the front of the queue. So dequeue method will not take any argument, as we have to pop the element at the front. So I will write here pop method and pass 0th index to it. So 0th element will be popped out from the list. Now let us try and enqueue some element. So I will write enqueue and pass 1000. Let us print our queue and run the code. So 1000 has been added to our queue. Let us add some more elements. So I have added 1000, 1002, 1003, 1004 elements to our queue. So dequeue method should remove the element at the front. So let us use dequeue function and try to print our queue again. Let us run the code. So you can see the element which is on the front, which is 1000, has been removed from our queue. So let us try and run the dequeue method again. Let us run the code again. You can see 1002 has been removed. Similarly, if you call enqueue again with some another number and run the code, it will be added at the end. And dequeue method will remove an element from the front of the queue. So this is how you can implement enqueue and dequeue functions of the queue using Python list. Now I hope you have understood the queue and stack and how to apply them using a Python list. Let us implement a stack using a single linked list. So I will create a new file in our DSA folder. So let us create a node class node. So let us initialize it using init method. So for a linked list, we have data and we have a next node. So let us initialize self dot next pointer as none and self dot data as data that we will be passing while creating a node. So we have created our node successfully. Now let us create a single linked list. So I will write SLL class. I will also initialize it. Now SLL class uh, will only have a head. So self dot head equals to none. So we have created a node class and a single linked list class. Now as we are implementing a stack using a linked list, we will have a push and pop method. So push method will push the element on the top of the stack, and pop method will pop an element from the top of the stack. Because stack follows first in last out method, which means element which is added first will be removed at the last. Now from our single linked list, we can use certain functions to implement push and pop method in a linked list. Now to implement push and pop method of a stack using a single linked list, we can reuse the functions that we have defined in a single linked list to implement push and pop methods. For example, I can use add element at any location to implement a push method and delete element at any location method to pop an element from the stack. So let us copy add element at any location method and let us rename this method with push, and let us copy the delete element method and let us rename this method with the pop. So we have all push and pop methods. So let us create a stack. So I will define a stack with some elements in it. So stack, as we are using single linked list to create a stack, I will write here SLL that will initialize a single linked list. Then we will create a stack with the help of that. SLL. So let us have a node with 100 in it. So stack dot head equals to a. So we have a as our head. Now let us copy the print functionality of our linked list. So print. So let us try and print our list as of now. So print list. I will pass it stack head. So let us run the code. So we have got the first element of our stack. Now let us try and push the element into our stack. So as of now we have only 100 in our stack. So let us add some elements at the end of our stack. So I will use push method. I will pass our stack into it. Then the element which I want to add, let's say 101, and the location, let's say it is 1. Print the stack and run the code. So 101 has been added to our stack. Now if I want to pop an element from the stack, I will use pop method. I will pass the stack over here, and I want to remove the element from the last. So I will pass here the element. So the element at the last has been removed. So I have made some changes in our pop method as we want to always remove the element at the last of the stack. So this while loop will help me to move at the last of the stack, and then I'm going to remove that element by using these steps. We have discussed these steps while creating a single linked list. So you can refer these steps over there by using this code. So this is how we can remove the element at the top of stack. So let us add some more elements into our stack. So let us add 102, 103, 104. So you can see now the element has been added to our stack. So let us try and pop some element from our stack. So I will pop the element and run the code again. So you can see 104 has been removed. So let us try and remove some more elements. So I have run the pop again 2 times. So 2 element must be removed, that is 102 and 103. So let us run the code. So this element has been removed. So this is how we can implement a stack using the singly linked list. Implement a queue using linked list. So let us create a class node. Let us initialize it with init method. We will be passing data to our node. So data and self.data is data. Then we have a next pointer. So self.next equals to none. Now let us create a class for singly linked list. Class SLL. Initialize it with init method. So we have a head in our singly linked list. So head. Let us initialize it with none. So we have created a node and singly linked list class. Now to implement queue, we have first in first out approach. So the element which is entered first should be removed at the first. So we have enqueue and dequeue method in a queue. So let us use our previous code to implement enqueue and dequeue method. So I will copy the push and pop method from a stack. Let us print that over here. So instead of push we have enqueue. So enqueue method will always add an element at the start. So instead of using a location parameter, I will define a location which will be always 1. So we will be adding element at the start always, and the pop method removes the element from the end. So we don't have to uh, change anything over here. Now let us change the name of pop method to dequeue. So after we have done that, so let us create a queue with singly linked list. Now we have created a queue. So let us create a node. I will create a default head node. So this will be our head. So queue dot head equals to h. So we have created head for our queue. Now let us try and add an element to our queue. So enqueue, I will pass our queue and the new element which I want to add, let's say 100. As we have added the element, let us copy the print function of the linked list. So print list. I will call print list and let us pass head, which is q dot head. Let us try and run the code. So we have head and we have added 100 to our queue. Let us try and add some more elements. Let's say 999, then 998, then 996. Let us run the code. So every element is being added at the first, as you can see over here. Let us try and add one more element. So this 100 should be added at the first position. So let us run the code again. So 100 is added at the first. So dequeue should be remove the element at the last. So let us try and run dequeue function. So let us try and run dequeue. So dequeue, and I will pass our queue to it. Let us print the queue again and run the code. So 100 at the last has been removed. So let us try and run dequeue some more times. So I have run the dequeue function 2 times. So as I have called the dequeue method 2 times, the two element, which is 999 and 998, should be removed from the queue. So let us try and run the code. So this two element has been removed. So I hope you have understood how to implement queue and stack using the linked list. Start learning about binary search trees. So binary search trees are also similar to linked list. As in a linked list, we have the next pointer. In binary search tree, we have left pointer and a right pointer, and each pointer is associated with another node, and that node also have a left pointer and a right pointer. The node which is on the top is called as root node, root. Then the node which falls below the root node is called as a child node. As this node is on the right of root node, so we called it as right child node. Similarly, as this node is on the left and it is a child of root node, so it is called as left child node. When we consider only this part of a binary search tree, this node become a root node, and this becomes a left child node, and this become a right child node. So as this node does not have any child associated with them, these nodes are called as leaf nodes. So these are all the main components of a binary search tree, where the first parent is called as root. Then the nodes below the root node are called as child nodes, and the nodes which are on the left side of a tree are called as a left child node, and the nodes which are on the right side of a tree are called as the right child node. When we consider a subtree in perspective, we also can call this 7 as a root node, and 6 as a left child node, and 8 as right child node. When the node does not have any child associated with them, then these nodes are called as leaf nodes. So as similar to our linked list, we also have pointers. As in a linked list, we have a next pointer. Here we have left pointer and a right pointer. And in between of this pointer, we have data. So whatever the data we have to store here. And in the left, we have a left pointer, and in the right, we have a right pointer. Then if this is a root node, then if I paste this here, then another node at here, and if I connect left pointer with the left node and the right pointer with the right node, then we can represent a binary search tree using these nodes. So here the data is 5, here the data is 3, here we have stored 7. So this is how we can represent a binary search tree using nodes. Now there are some points which we have to remember while creating a binary search tree. So in a binary search tree, every parent should have only two children. If we consider 5, then it has 3 and 7 as the children. If we consider 3, then it has 2 and 4 as the children. And if we consider 7, then we have 6 and 8 as the children. So this is a valid binary tree. If we add one more children to 7, then it will become an invalid binary tree. The binary tree to be valid must have only two children with respect to every parent. Now let's see another condition. So every node in a left subtree contains the less value than its parent. So every parent must have a greater value than considered to a left child. So when you consider 3, then 5 has a greater value than 3. So this satisfies our condition. When we consider 2, so 2 has lesser value than 3. So this also satisfies our condition. So when we consider 7, 6, which is lesser than 7, so this also satisfies our condition. So every parent element must have a greater value than its left child. So this is the second condition. Now let us see the third condition. So every right subtree must have a greater value than the parent, which means every right child, when we consider 5 as our parent, then the 7, which is the right child, must have a greater value. So therefore, that is 7 is greater than 5, therefore it satisfies our condition. Similarly, 8 has a greater value than 7, so it also satisfies our condition, and 3 has a greater value than 4, so it also satisfies our condition. That is, every parent element must have a lesser value than its right child, and every parent element must have a lesser value than its left child. So this is the second and third condition. Now let us see what is fourth condition. So left and right subtree each must also be a binary tree. So the right and left subtree, that is this and this, must also satisfy all the binary search tree conditions. That is, every right child must have a greater value than parent, and every left child must have a lesser value than parent. So let us create a binary search tree using the conditions we just have learned. So I will create a new file, binary search tree. So as similar to a linked list, we have a node, and instead of the next and previous pointer, we have left and right pointer. So let us create that. So we have a node. So let us create a node, class node. Let us initialize it using init method. Then we have a left pointer and right pointer. So let us create that. Self.left. Let us initialize with none. Self.right. Let us also initialize this with none. Now we have data to store. So let us accept a data as a parameter for data. So self.data is data. So I am storing data here. So we have created a left pointer, right pointer, and a data. So we successfully have created a class to create a node. Now let us see. Now in our binary search tree, our root child is also a node. As we have seen here, our root is also a node. So let us create a root with the node class we just have created. So our root was 5. So let us write 5 here. Then let us create another nodes of our tree, which were 3, 7, 2, 4, 6, 8. So A. Now we have created all the required nodes of our binary search tree. Now let us see our binary search tree and let us create that using our nodes. So we have a root at the top. So our root. Now our left child is 3. So root dot left is 3, which is A. Then our right is 7. Then root dot right is B. Similarly, now when we consider this subtree, then our parent becomes 3. So our left child has become 2. So A's child, so A dot left is 2, which is C, and A dot right is 4, which is D. Similarly, we have 7. So 7 is B. So B dot left. So B dot left is 6. So which is E. So we'll write E. Similarly, B dot right is 8. So F is our 8. So we will write it as F. So we successfully have constructed our binary search tree using these nodes. So I hope you have understood the basic concept about binary search tree and how to write a Python code for binary search tree. See what are the traversal methods in binary search tree. So we mainly have 3 methods of traversing in binary search tree, which are Inorder traversal, Preorder traversal, and Postorder traversal. In Inorder traversal, we start from the left, then we go to root, then we go to right. If we consider the example with only 3 nodes, which is 5, 3, 7, then Inorder traversal will be left, left, root, and right, which means 3, 5, and 7. Then we have preorder traversal where we access the root first, then left and right, that is 5, then left, which is 3, and right, which is 7. In the post order, we go for left, right first, and then root, which means we go for 3, then 7, which means left and right, and then we go to root, which is 5. So these are the 3 main methods of traversal in BST. So if we take the whole example into the consideration, so what will be the output? So we want left first. So we will start from 5. We will search is there any left. So 3 is left. So we will search is there any left for 3. So there is 2. So for 2 we will search if there any left for 2. So there is no left remaining here. So we will print the 2, which is the leftmost element. Then we have to print the root of leftmost element, which is 3. Then we will check if there is any right for 3. So there is right for 3. Then we will check if there is any left element for 4. So there is not. Then we will write 4 here, and we will check if there is any right element. So there is no right element for 4. So we will go to root, and then we will reach at 5 because there is no more element remaining to search in this left subtree. So as we have reached to the 5, right here 5, and then we will go to right. So right. So at 7 we will check if is there any left element. So we will go to 6, and at 6 we will check if there is any left. So there is no left for the 6, so we will write 6 here. Then we will check if there is any right for 6. So there is no right, so we will go to our root, and then we will go to the right, which is 8. Then we will check if there is any left. So there is no left, then we will print 8 here, and after printing it we will check if there is any right. So there is no right, so we will stop here, and after stopping we will get our answer as here. So this is very simple to understand, and also it is very simple to code using recursive method. So let us try to implement the code using recursive method. So I will write in order. So we will be taking root as our input, which is the root of our tree. So root, I will write our sequence here. So left, then root, then right. So our base condition will be if we find root is none, then we will return, which means there is nothing in the root, then we will stop. Then let us recursively call this function. So in order, and we want to go to the left child first, so we will write left. So root dot left, then we will print the element root dot data. As we want to print all the elements in single line, so I will write end equals to space, and I will again recursively call the function. As we want to traverse the right subtree, after traversing the left, then we will go to root, then we will go to right. So root dot right. So let us try and run this. So in order, then we will pass root of our tree, root. Let us run the code. So we get the output as 2 3 5 6 7 and 8. So let us see if it is same. So 2 3 4 5 6. Oh, I forgot to write 7 here. So we got a same output. So let us see how this code will work. So we will start with 5 as we are passing our root. Then if it is none, we will stop running the loop, because there is no chance of going forward if the root is none. But we have our root. So after checking the base condition, we will pass our root dot left in the function. So we will pass 3. So 3 will be passed, and we will check if it is none. So it is not none, so again in order function will be called with 2, as we are passing root dot left. So 3's left is 2, so it is checked, and again it is check if it is none or not. So it is not, so again we will pass root dot left. So 2's left will be passed, then we will check if it is none. So it is none, so we will stop iterating over that. After this we have the print statement. So we are at 2 right now, so we will print the 2. So I will write over here. So we will print the 2, and then we will go to 3, because previous element which we have traversed, which was 3, so we will go to 3. After going to 3, we will print the data, which means we will print the 3, and after that we will go to right, which is 4. So we will print here 4. After that we will go to right, which is 4. So we will check if it is none or not. So it is not. So we will again check if it has the left element. So 4's left will be passed, so it is none, so it will be returned. So we will print the data of the 4th node of this node, so it will be 4. Then we will go to the right element of 4, so we will pass that, and it will return us nothing. So it will go back over here, then it will go back to 3, then it will go back to 5. So after reaching 5, it will be at this position. So we will print 5, then we will go to right, because after that we have right. So we will go to 7. After passing 7, then we will check if it is none or not. So it is not none. So we will check the root dot left, which is 6. So we will check if 6 has left or right. So there is no left or right for 6. So we will print 6. Then we will go back to 7. Then we are here right now. So we will print 7. Then we are checking the right. So we will go to 8. Then after passing it, we will check if it has left, and then it does not have left, then we will print it. And we will check if it has right. So there is no right for it, so we will stop here. So this is how we will be iterating using recursive function. I hope you have understood this code. Let us see remaining traversal methods. And the second one is preorder traversal. So here we will print the root first, then we will print the left, then we will go for right. So for our example, 5 is our root. So after reaching to the 5, we will print that first. Then we will go to the left element, because we have left here. So left. So as 3 is the root, we will print the 3. Then we will go to the 2. So there is no more left. Then we will check if 2 has right or not. So there is no right. So we will print 2. Then we will print 4, because we have to go left right. So we have printed 3, then 2, then 4, root, left and right. Then we will go to right subtree. Then after going to 7, we will get our root. So we will print 7. So then we have to go to 6, left, and then we have to go to 8, which is right. So 6 and then 8. So this is how we will be traversing. So let us implement this. So define preorder, take the root of our tree. Let us write the traversing sequence, which is root, left and right. We will first check the base condition. If root is none, then we have to return. As we have to print the root first, so after reaching to the 5, we have to print it. So I will print the root first. So print root dot data. I will write end equals to space. Then we have to go to left subtree. So preorder root dot left. So this will help me to traverse the left subtree first. And after traversing to the left subtree, we have to go to right subtree. So I will write preorder root dot right. So let us call this function preorder, and I will pass our root to this function. Let us run this code. Everything printed on the same line. So I will print an empty space here. Print. Let us run the code again. So we have got an output. Let us see if it matches with our output. So 5, 3, 2, 4, 7 and 6, 8. So it does match with our output. Now let us see how this code works. So first we will check base condition, that is if root is none, we will stop there. If it is not, then we will print the root data, as we have to print the root first. Then we will go to the right subtree, that is 3. So after getting to the 3, we will check if it is none or not. So it is not none. So we will print the data, which is 3 will be printed. Then we will again go to root.left. So 2 will be passed. So 2. So 2 is not none. So we will print the data, that is 2. I will quickly write that here. We have gone to 5, then 3, then 2. Then there is no more element remaining. So then at the last we will go for root.right. So root.right will be checked if it is none or not. So it is not none. Then we will go and print the 4 here. Then after that we will go for right subtree. So at the right subtree we will go to 7. Then we will check if it is none. It is not none. So we will print 7. Then we will go to 6 and check the left then check its left subtree and right subtree. Then both are none. So we will print 6. Then we will go to 8. We will check whether it has a left subtree or right subtree. So it does not have both of them. So we will print 8 at the last. So this is the same thing we are getting over here. Now let us move to the post order traversal. So we will go to left. Then again we will check if there is left. So there is 2. So we will print the 2. Then we will go to right. That is 4. Then we will go to root, which is 3. Then we will check we have right or not. So we do have right. So we will go to right first. Then we will check if it has left. So 7 has left. So we will go for 6. Then left has done. So we will go to right. So which is 8. Then we will go to 7, which is the root 7. And at the last we have to go to 5 and print that. So in this way we have to traverse in post order. So let us implement the code. Let us print the empty line first and let us create a function. Define post order. Here also we will take the root. I will copy our post order sequence. So this is our post order sequence. Our base condition will be the same. So if root is none, we will return. That is, we will stop executing. Then we have to print the left first. So post order root dot left, as we have to go and check all the left subtree first. Then we have to check the right subtree. So post order root dot right, and then we have to print the root. So I will write root dot data, and I will write end equals to space. So we are checking for the left, then we are going to right, and then at the last we are printing the root. So left, right, and then root. So let us call the function and pass it the root, and let us try and run this code. So we have got the solution. Let us see if it matches with our solution or not. So 2, 4, 3, 6, 8, 7 and 5. So it does match with our solution. So you must have got an idea how it works. So let us do this. So we will pass our root. So we will check if it is none. So it is not. We will pass our left child, which is 3. Then it will again pass the 2. Then there is no more left child for this, and then it will check for the right child here. So there is no right child. So we will print the data, which is 2. I will close this here. Okay. So after printing the 2, we will reach at 4. Then we will check if it has the left child or not. So there is no left child. So and there is no right child. Then we will print the data of root, which is 4. So we have printed 4 here. So we will go to 3. So 3 is our root. So we will print 3 here, and then we will go to the right subtree. After going to right subtree, we will check if it is none. So it is not none. So we will call root.left here. So we will go to 6. Then after going to 6, we will check if it has a right. So there is no right for the 6. So we will print 6 here. So we will go to right after this. So at 8. So at 8 we will check if it has left and right. So it does not have any. So I will write 8. Then we will go back to the 7. So 7 is our root. So I will print 7 here. And after all this has ended, we will go to our root, which is 5. I will write that here. So let us see if it is same or not. So 2, 4, 3, 6, 8, 7 and 5. So this is how we have to traverse in order, then pre-order, and in a post-order manner. So I hope you have understood the recursive methods. See how to insert an element into a binary search tree. So in order to insert an element into a binary search tree, it must follow all the conditions that needed to be true for the tree to be a binary search tree. So let us read all those conditions. So the first condition is the parent should have only 2 children. Then left subtree of a node contains value lesser than the parent. Then right subtree of the node contains greater value than parent. As we can see here, the left subtree has lesser value than parent and right subtree has the greater value than parent. And left and right subtree must also be a binary search tree. So left tree must also be a binary search tree. That means it also follows the same conditions. That is, the left value should be lesser and the right value should be greater than the parent value. So let us see how to implement this. So here we have given an example to create a binary search tree. So from this number we have to build binary search tree which follows all these conditions. So here is the piece of code that we will follow while creating a binary search tree. Now let us understand this code. So the first statement is we are defining the insert function and we are taking a root and a key that we want to add. So we are taking a key that we want to add, but instead of key we have used data while creating our binary search tree. So this is one and the same. So we are taking root and the key. Then we are checking if the root is none, that is there is no tree created. So if the root is none, then we are creating the node for root and we are returning the root as the first node. Then after that, our second condition was the left subtree should contain lesser value than the parent. That means if we get the lesser value than parent, then we will insert that node to the left side of tree. That is, we are traversing to root dot left, which means the left side of the tree. And the third condition was the right subtree values should be greater than the parent, which means if this condition is not true, which means the value is greater than the parent, then we will go to the else condition and we will insert that value to the right side of the tree. So this is how this program will run. Now let us solve this example. First we have 5, so we have inserted 5, so our key is 5. Now we will check if there is a root. So there is no tree up till now, so the root is none. So what we will return? We will return a node of key. So we will create this 5 as a node and we will return this. So we have 5 here and it is a root. So by following this first if statement, we have created a root as 5. Now we will get 3 and pass this to the condition. Then we will see if root is none. So root is not none because we already have 5 as a root. So we will check if the key is lesser than root, which means 3 is lesser than root. Then this condition is true. Then we will insert this. So we will pass this key to the left side of the root. So let us create that. So I will draw an arrow to the left, and here we have 3. Now we will go to 7. In 7 we will check if the key is less than root dot key. So we are now here at the root. So it is not lesser. So we will go to right and insert that. So we will go here and insert here 7. Then again we will start with 8. Then we have 8. If 8 is less than the key, it is not. We will go with the else condition, that is we have to insert it to right. So we will pass here root dot right, but there is a root dot right present. So this insert statement will again call with the same key, which is 8. Then it will go to again right of that. So it will go again to the right, and as there is no right here, so it will add 8 at this position. Now we will get 2 as a key. Now this condition is true, that is key is less than root, that is 5. Then we will go to 3 and we will again check if key is less than root, that is again true. Then we will go to again left because this condition is again true. Then after going to again left, we will see if there is any element. So there is no element, so we will add here the 2. Now we will have 4. So for the 4, so now we have 4 as the key. So if we will check this condition, if root is none, so root is not none. So then we will check if key is less than root dot key, that is key is less than 5. So the answer is yes. So we will go to 3 and we will check if the key is less than the root, which means 3. If it is less, so the 4 is not lesser than 3. So we will go to else condition and we will go to the right because here it is root dot right. So 3 dot right will be here. So there is no other element to check. So we will add 4 here. So here it should be 6 as it is already added previously. So we are at the 6. We will check if the root is none. So we have root as 5, so it is not none. Then we will go to second condition if key is less than root dot key, that is whether 6 is less than 5. So this condition is false. So we will go to right, that is we are on the 7. Then again we will check if it is none. So it is not none. So we will go to second condition if it is less than 7. So this condition is true. So when this condition is true, we go to left. So we will go here and we will check if it is none. So it is not none. Then we will add 6 over here. So we have added all the element that we have given. So let us check this with the original tree we have. So this is our original tree and you can compare this with the tree that we have created, that we have 5 on the top, then 3 7, 2 4 and then 6 8 6 8. So this tree matches with the tree that we have created. So we have got the right solution. So let us implement this code in our Python. So let us copy this. I'm at the PST file. So let us paste our insert statement over here. So instead of inserting the nodes manually, so let us try that using a function. So here we have to insert a 3. So I will write insert and I have to pass the root and I have to pass the 3. Then similarly 7, 2, 4, 6 and 8 we have to add. Let us do that. So we have inserted all the nodes. Now let us say we get the same thing for the Inorder traversal as we previously was getting. So let us comment the remaining code out and let us try and run this code. So instead of the key, we have used data over here. So I will change key to data. So data and run the code. So we have got 2, 3, 4, 5, 6, 7 and 8. So this is the same solution as we previously was getting. So this is how you can insert the node into a binary search tree. I hope you have understood how to insert an element into a binary search tree.